सर को बोलिए मास्क पहनने के लिए।
Ma'am, Professor Dolly Sinha, ma'am, our today's guest of honor, Dean Faculty of Science, Professor R.K. Chaudhary, sir, the pride of our students, Dean Student Welfare, Dr. A.K. Jha, sir, our backbone of the university, the Registrar, Professor Mustaq Ahmed, sir, our guardian, as a president of the seminar, Professor Arun Kumar Singh, sir, and our ex faculty Professor Arun Kumar Mishra, sir, our well experienced keynote speaker Professor Poonam Tandon, ma'am, and Dr. Vijay Raj Singh, sir, dignitaries of the dais, faculties, postdoctoral fellow, PhD scholars, dear students, media persons, and everyone. This seminar, a warm welcome to all of you on this glorious academic event. Now, further proceeding of this event, I am handovering my charges to my co-host Sakshi Jha and Salpriya. Thank you.
Thank you so much, sir. I, Sakshi Jha, on the behalf of University Department of Physics, Lalit Narayan Mithila University, extend a very refreshing sun up and warm greeting to all the dignitaries and our honorable guests and respectable keynote speakers for their valuable presence, marking the significance of this magnificent event. We would also love to extend a gracious welcome to all our colleagues, volunteers and students present with us. Last but not the least, I would appreciate the presence of all the participants wholeheartedly who are connected to us via virtual platforms, that is Facebook Live on departmental page, Google Meet and YouTube, to manifest the importance of this glorious occasion. I would humbly request our volunteers and students to kindly put their phones on silent mode. for the hassle-free proceedings. सभी श्रेष्ठ गणों को सादर नमन and a very great morning to all my friends. We are very fortunate to share this moment with you all after a very long time of struggle and hardships. It is a moment of happiness and warmth to have you all with us. So let us give a momentum to this very much awaited event. संस्कृत का एक श्लोक है, गुकारस्त्वंधकारस्तु ऋकार स्तेज उच्यते अंधकार निरोधत्वात् गुरुरित्यभिधीयते। अर्थात जो अंधकार को दूर कर ज्ञान रूपी प्रकाश का संचार करते हैं वही श्रेष्ठ जन हमारे गुरु कहे जाते हैं। तो आज हमारे सभी गुरुजन, सभी श्रेष्ठ जन हमारे साथ उपस्थित हैं। हम आग्रह करेंगे अपनी ऑनरेबल प्रो वीसी मैम से तथा सभी डिग्निटरीज से कि वो आगे आए और दीप प्रज्वलन की परंपरा को संपन्न करने की कृपा करें। थैंक यू।
से उसको आगे कर सकते हो, गाइड कर सकते
हो। मुंह पर से हटे नहीं है, साइड से खींचो ना, नहीं हो पाएगा। आगे से खींचिए, ठीक है, में नहीं होगी कैमरा अखबार में छपते की करत से एकरे सहाय होय छै, ककरा धऽ देत ककरा उड़ा देत।
आप सभी से आग्रह है कि मां सरस्वती की प्रतिमा पर माल्यार्पण कर
एक जगह करके दीप प्रज्वलन के साथ
I request all the dignitaries कि वो मां सरस्वती की प्रतिमा पर माल्यार्पण करने की कृपा करें, पुष्पांजलि अर्पण करें। सरस्वती नमस्तुभ्यं वरदे कामरूपिणी विद्या आरंभम करिष्यामि सिद्धिर्भवतु मे सदा। इन्हीं शब्दों के साथ हम मां सरस्वती का आशीर्वाद लेते हुए अग्रसर होंगे। Thank you, Honorable Pro VC Ma'am and all the respectable dignitaries for the rituals. Now it is the time for felicitation. For that, I would like to call Shaili Priya to do the further proceedings.
Thank you for giving privilege. Being a man is a matter of earth, and being a woman is a matter of heaven, and being a human is a matter of joy, bliss and happiness. And same as we are blessed to have all of them. To celebrate this, we would love to request our man of means, our head sir, which have to grace us the great of the academy of proficiency and forbearance, Professor Pro VC ma'am, with a gift of greenery and nature. President sir for the facilitation. We would kindly request to the DIGORG's organizing secretary to facilitate the respected and magnificent man, the Dean sir. Thank you, sir. For the arithmetic man, our convener or Dr. Ritesh sir will now pay the honor our kind-hearted and student passionates. Thank you, Dr. Ritesh sir, for the virtue. We would again request our President sir to greet warmly with the very respectful Professor Mustaq Ahmad sir, our University Registrar. Thank you, sir, for the gracefulness. We would humbly request to Dr. Ritesh sir to pay the warmth of respect to our dear Professor Arun Singh sir, the head of the department. Thank you so much for the greetings. Last but not least, we request most humble teacher, Mr. Vinay sir, to kindly rectitude our convener. Respected. Thank you, sir, for the greetings. Last but not least, we request most humble teacher, Mr. Vinay sir, to kindly rectitude our convener, respectable Dr. Ritesh sir. Thank you so much for the privilege.
Thank you so much. It is now our humble request to Honorable Pro VC Ma'am to release the souvenir cum abstract book cover page. I would call Manisha for the same. Thank you so much, all the dignitaries. We now wish to solicit Dr. Ritesh Chaurasia sir to kindly come forward and introduce the very theme of today's national event on cutting edges in material sciences.
Thank you, Sakshi. Thank you, Salpreet. A very warm welcome to all of you. As the title of the seminar, Cutting Edges in Material Science, itself contains the sole concept of ultra-modern, innovative synthesis techniques, just like 3D printing technology, ultra-ace laser-induced cutting technology for desired shape, thin film preparation, molecular beam epoxy, ambient temperature-dependent thermal evaporation technique, and furthermore various atomic, molecular, surface morphological, thermal, electrical, optical, magnetic, mechanical characterization techniques. For example, XRD, X-ray diffraction, differential scanning calorimetry DSC, TGA, scanning electron microscopy SEM, transmission electron microscopy TEM, optical microscopy, UV visible spectroscopy, FTIR, photoluminescence, XPS, hardness measurement, LCR meter for electrical measurement, neutron diffraction technique to find out the specific material preparation for desired device preparation. The most beautiful thing originates from this national seminar today. We will all aware and see the detailed perception of the above said synthesis and characterization techniques by our eminent two keynote speakers, Professor Poonam Tandon ma'am, who is online here, and Dr. Vijay Raj Singh sir. Total 9 invited talks across the country, faculty members and postdoctoral fellows, and last but not least, our 52 research scholars across the country. So it's a pleasure and opportunity for all of us to learn the cutting edge things and technology, share our thoughts and ideas on this common forum freely, and get bona fide with this glorious academic event. I wish blessings from all dignitaries on the dais and off the dais and online keynote speakers for the successful completion of this event. Thank you so much.
Thank you so much, Ritesh Chaurasia sir, for the very informative session. Now it is our request to our head sir, our president, Professor Arun Kumar Singh sir, to deliver his words of welcome for the dignitaries and the participants.
Sir, very good morning to all of you. Due to busy schedule, Honorable VC sir is out of the station, but sir is mentally and heartily present here. It is our privilege and honor to welcome our Vice Chancellor, Professor S.P. Singh sir, for his blessings to this seminar. Transitional states are among the most difficult to characterize and understand. We experienced a similar state after the departure of our previous Vice Chancellor, Professor S.K. Singh. Since the day our present Vice Chancellor joined the university, that slip inertia went away, and with his magnificent efforts, we are feeling an all-round improvement in teaching and learning environment and the student experiences in LNMU. I greatly appreciate his steadfast judgment and caring behavior. I hereby express my heartfelt gratitude to our Honorable PVC, Professor Dolly Sinha ma'am, whose brainchild has been the series of seminars and conferences that we are presently witnessing in different PG departments of our university. Whilst not residing from her views, she has been very graceful and collegiality. Professor Sinha has done her PhD degree from IIT Delhi, a benchmark institution of our country. She is an eminent scholar of physics. Faculty and students of physics are very much fortunate to have such a golden chance to learn from a great personality like her. Now I extend my gratitude to Dean Faculty of Science, Professor R.K. Chaudhary, who has regularly guided and advised us for the successful organization of this seminar. At present, he is one of the senior most teachers of about 64 years old. Yet young teachers learned a lot from his zeal, enthusiasm and working ability. I feel our university will need him after his retirement. I welcome our DSW Dr. Ashok Kumar Jha, who is highly energetic and sociable. His pleasant and friendly behavior has reduced the problem of the university. I welcome our registrar, Professor Mustaq Ahmad sir, a dynamic personality. He is ready to work and support round the clock, that is 24/7, for the all-round development of the university. Our Vice Chancellor is giving wings to our dreams, while our registrar sir is endeavoring to make it true tuning between the two has been quite marvelous. I extend my welcome to Dean of different faculties, HODs, and faculty members of different PG departments, Director Distance Education, Director WIT, principals and also teachers of different colleges over here. Due to their gracious presence, this seminar has become more special. My heartiest welcome to former HODs and faculties of this department who are present here or connected virtually, they have given their blessings for the success of this seminar. Now, I welcome resource person of today's seminar, Professor Poonam Tandon of Lucknow University and Professor Vijay Raj Singh of Central University of South Bihar, Gaya. They are internationally recognized in the field of material science. I hope all participants will feel enlightened their lecture. On behalf of my institution, I welcome all students, research scholars, and paper presenters joining from various parts of our country. Papers to be presented here by the participants would surely show us how changes in material science affect our life. Last but not the least, I welcome our media personnel from electric and print media who have taken pain to cover this event today. I hope they will give more and more space in their channels and newspapers regarding the activities of this e-seminar and will make it successful. Friends, we all live in the same world, but we often forget it. Science doesn't. Every day, science reminds us that we need to share knowledge, technologies, and good practices with fellow citizens and scientists for sustainable development of our planet. Materials are the bricks of our present and steps to our future. Advances in materials have preceded almost every technological leap since the beginning of the civilization, and engineered materials are crucial to the continued vitality of countless industries. Fast technological changes have enabled the world to experience a material revolution. The present seminar focuses on such cutting edges in material science. I would like to close my speech by expressing my sincere wishes for the success of the seminar and for all participants to discover new opportunities in the still growing area of research on material science. My thanks to all of you for your patient learning. Namaskar.
Thank you so much, sir. Now we are delighted to have us Professor Poonam Tandon ma'am, Head of Physics Department, Lucknow University with us. She is a awardee of Alexander von Humboldt Research Fellowship, Germany, Usha Vijay Sodh Prize for Scientific Research, Young Scientist Award and Nature Publishing Group Awards, and many more. We would request our very dignified and proficient keynote speaker, Professor Poonam Tandon ma'am, to please kindly share her words with us. Due to some technical issues, she is not here. Now it is the time. We would extend our request for 2 words of wisdom from our respectable registrar, sir.
हरित नारायण मिथिला विद्यालय के माननीय सम्मानित प्रतिकुलपति महोदय प्रोफेसर डॉली सिन्हा साहिबा, मंच पे आसीन विज्ञान संघ के अध्यक्ष प्रोफेसर रतन कुमार चौधरी साहब, ये सभागार में उपस्थित डीन ह्यूमैनिटीज प्रोफेसर प्रीति झा साहिबा, हेड बच्चन साहब, अन्य सम्मानित शिक्षकगण, छात्र छात्राओं और ऑनलाइन जुड़े हुए इस सेमिनार से तमाम अतिथि सहभागी, सर्वप्रथम आपके प्रति, विभाग के प्रति आभार कि आपने मुझे यहाँ बुलाया। आपके बुलाने से ज़्यादा एक आदेश का पालन भी है कि माननीय कुलपति महोदय का आदेश हुआ कि आज सेमिनार हो रहा है, माननीय प्रति कुलपति महोदया वहाँ जा रही है। अगर 5-10 मिनट का समय हो तो आप लोग भी जाइए, ताकि विश्वविद्यालय में जो सेमिनार हो रहे हैं तो उसमें पूरे विश्वविद्यालय परिवार की सहभागिता हो। लेकिन ये जो हंगामा, इल्मी बौद्धिक हंगामा है इस परिसर में, उसका श्रेय सिर्फ और सिर्फ अगर जाता है तो उसकी बुनियाद डालने में हमारे प्रति कुलपति महोदया और कुलपति का है कि विश्वविद्यालय में जो कोरोना महामारी के कारण शिथिलता आ गई थी, तो मैं तो साहित्य का छात्र हूँ, ऐसी बात है विज्ञान मेरे पल्ले इस तरह पड़ती है कि जब मैं शब्दों को शेर के कालिब में ढालता हूँ तो वो सारे विज्ञान अगर ना जाने तो शायरी नहीं बनती। इस रूप में विज्ञान हमारी समझ में आता है। तो किसी ने बहुत पहले एक शेर कहा था कि अगर आपको समझना हो दुनिया को तो किसी झील में एक कंकड़ फेंकिए, झील में पत्थर मत फेंको, कहकर एक पत्थर फेंकिए, फिर बनते हुए दायरे को किनारे तक जाते देखिए। समंदर में भी अगर आप छोटे कंकरी फेंकेंगे तो जो हलचल पैदा होगी तो उसका अंत उसके किनारे में होता है। तो वो जो तरंग है वो मैं समझता हूँ कि फिजिक्स से जुड़ी हुई चीज है। हमारे अल्लामा इकबाल ने कहा था कि सितारों से आगे जहां और भी है, तो जाहिर सी बात है कि हर उर्दू वाले को ये सोचने पे मजबूर किया था कि विज्ञान भी जानना चाहिए कि सितारों के आगे भी कोई भूमंडल है, दुनिया है। लेकिन मेरी हालत ये है कि मैं तो शुरू से साहित्य का विद्यार्थी रहा, और साहित्य के विद्यार्थी की मजबूरी ये होती है कि किसी चीज पर वो दस्तरस नहीं रखता, लेकिन हर चीज के बारे में थोड़ी थोड़ी चीजें बोल सकता है। क्योंकि उर्दू शायरी में कोई ऐसा मौजू नहीं है जिस पर शेर न कहा गया हो। बिलखुसूस गालिब के यहाँ बहुत ज्यादा शेरी इफाम व तफहीम, यानी आप उसको कह सकते हैं कि कम्युनिकेशन, डायलॉग जिसको कहते हैं, वो पूरी की पूरी शायरी गालिब की जो है वो किसी न किसी विधा से जुड़ी हुई है। गालिब के हर शेर पर अलग अलग अब तक 12,000 किताबें लिखी जा चुकी हैं, और सबसे अहम बात यह है कि गालिब के शेर पर एक पूरी साइंस की किताब लिखी जा चुकी है। और वो शेर सुन लीजिए, वो क्या है कि अक्ल में जो घिर गया ला इंतहा क्यों कर हुआ, अक्ल में जो घिर गया ला इंतहा क्यों कर हुआ, जो समझ में आ गया फिर वो खुदा क्यों कर हुआ। लेकिन दूसरे शायर की मजबूरी ये थी कि मैंने कभी एक शेर कहा था कि यही जाना कि कुछ न जाना है, यही जाना कि कुछ न जाना है, सो काश हम भी फिजिक्स पढ़े होते। तो मैं विश्वविद्यालय का एक सहयोगी हूँ, उस रूप में विभाग अध्यक्ष महोदय को मुबारकबाद देता हूँ और आशा करता हूँ कि यह गतिविधि सिर्फ एक रोज की हंगामा आराई नहीं होगी, बल्कि ये सिलसिला चलता रहेगा। कि ये इच्छा है कि विश्वविद्यालय जीवंत हो, और विश्वविद्यालय की जीवंतता क्लासरूम के पाठ्यक्रम से नहीं होगी, हमारे छात्र छात्राएं, रिसर्च स्कॉलर यदि विश्वविद्यालय का जो बढ़त का समय है उसके बाद अपने विभाग में टिकेंगे, अपने विभाग में रहेंगे, शोध के कार्यों में जुटेंगे और शिक्षकों से वर्ग के अलावा जो कम्युनिकेशन है, बातचीत करेंगे, वार्तालाप करेंगे विषय वस्तु पर, तो मैं समझता हूं कि ये सार्थक होगा हम लोगों का प्रयास। इसलिए कि विश्वविद्यालय, मैं समझता हूं कि 20-25 सालों के मुझे याद है कि कभी भी सभी विभागों को इस तरह की डीन साहब बताएंगे कि कभी भी हमने विश्वविद्यालय से ये नहीं सुना था कि छोटी ही रकम लेकिन दी जाए। पहली बार माननीय कुलपति महोदय के आदेश पर, कुलपति के आदेश पर हमने दिया और प्रतिकुलपति महोदय का आदेश ये भी है कि ये सिलसिला जारी रहनी चाहिए। तो विश्वविद्यालय उसके लिए तैयार है। मेरी भी इच्छा रहती है कि इस तरह की गतिविधि में शामिल होता रहूं, लेकिन मेरी व्यस्तता है। लेकिन फिर भी सीखने की ललक कभी कभी आप लोगों के बीच ले आती है, क्योंकि सीखना जिंदगी का हिस्सा है। तो इसलिए मैं यहाँ आया कि लफ्ज़ो मानी में टटोलने की आदत सी है, लफ्ज़ो मानी में टटोलने की आदत सी है, बस जां फलक यही तो राहत सी है। तो ये सोचने समझने जो है वो राहत होती है, इसलिए मैं आता हूं। आज दुनिया, मैं पिछले साल बेंगलोर गया था, तो साइंस का विद्यार्थी न रहते हुए भी पहले मैं वहाँ जो इंडियन साइंस इंस्टीट्यूट में वहाँ गया, तो मैं पूरे दिन उसमें रहा, पूरे दिन घूमता रहा। एक जो मेटाफर फिजिक्स डिपार्टमेंट है उसमें भी गया, तो वो आदमी बहुत गौर से मुझे कहा कि आप देख क्या है यहाँ। तो वो उन्होंने सामने विभागों के आगे चित्र बनाया था बहुत सारा, तो मैं उसको बहुत बारीकियों से देख रहा था कि इन्होंने क्या बनाया है। तो इत्तेफाक की बात यह है कि वो बंगला नोइंग थी, तो उन्होंने दूसरे से कहा बंगला में, लेकिन उन्होंने ये नहीं समझा हुआ कि मैं बंगला समझता हूँ। तो उन्होंने कहा कि ये आदमी बहुत देर से यहाँ खड़ा क्यों है, उसे पूछो। तो हमने बंगला में उन्हें जवाब दिया कि मैं कुछ समझने की कोशिश कर रहा हूँ। तो उन्होंने, वो बहुत खुश हुए। मैंने देखा कि एक बहुत सा तार का गोला जैसा बनता है वैसा बना हुआ है और सामने रखा हुआ है और उसके सामने बहुत से बटन सब लगे हुए हैं, तो हरे पीले लाल ये सब पूरा। उन्होंने कहा कि ये तरंग की गति जांचने के लिए छात्रों को जो हमारे यहाँ आते हैं रिसर्च स्कॉलर, पूरे के पूरे इस तरह का बड़ा हॉल था, उसमें जगह जगह लगा हुआ था। तो उन्होंने कहा कि आप इसको किसी को दबाइएगा तो आपको ये पता चलेगा कि ये अभी जो है इस वायुमंडल यहाँ पे वातावरण में तरंग की गति क्या है, वो आपको बताएंगे। ध्वनि की गति क्या है, पेड़ अगर हिलता हुआ रहेगा तब भी हम बता देंगे आपको कि यहाँ के उष्मा जो है, ऊर्जा जो है वो क्या है। ये उसके जो फिजिक्स के अलग अलग डिपार्टमेंट वहाँ बने हुए हैं, ये मेटाफर अलग अलग बोर्ड लगे हुए हैं, उसमें वो लगा हुआ है। तो मुझे लगा कि विज्ञान के कारण ही अगर हम चांद पर गए हैं और समुद्र की तहों में गए हैं, तो इसका कारण सिर्फ और सिर्फ ये है कि मनुष्य के अंदर जो सोचने समझने की ताकत है उसका उपयोग वो सही दिशा में कर रहा है। हमारी आपसे अपील होगी, खास करके छात्रों से, छात्राओं से, कि आप अपनी सोच को सकारात्मक दिशा में ले जाएं, कि आपकी सकारात्मक सोच से ही देश की दशा और दिशा बदलने वाली है, समाज की तस्वीर और तकदीर बदलने वाली है। धन्यवाद।
Thank you, Registrar Sir, for the great and warm speech. Now it is our kind request to our person for our welfare, DSW sir, to deliver words of knowledge for all of us.
माननीय प्रतिकुलपति महोदया डॉली सिन्हा जी, साइंस डीन प्रोफेसर रतन कुमार जी, प्रॉक्टर साहब अजय नाथ जी, रजिस्ट्रार साहब मुश्ताक अहमद साहब, टीओ साहब के साहू, सीसीडीसी सुरेंद्र कुमार और अरुण कुमार मिश्रा जी, पूर्व विभागाध्यक्ष अरुण कुमार सिंह, वर्तमान विभागाध्यक्ष, और चौरसिया जी, इस सभागार में उपस्थित विभिन्न महाविद्यालयों विभागों से आए हेड, डीन, आप सब और छात्र छात्राओं और कर्मचारी जो इस सेमिनार को सफल बनाने में लगे हुए हैं, उन सबों के भीतर बैठे हुए आत्मा रूपी परमात्मा को मेरा नमस्कार स्वीकार। की नोट देने के लिए प्रोफेसर पूनम टंडन जी, HOD लखनऊ विश्वविद्यालय, और दूसरे विजय राज सिंह जी, ये भी हम लोग ये गया से हैं और ये भी हम लोग को देंगे। अब बीच में फिजिक्स के बीच में रसायन हर्डल हो, ऐसा नहीं होना चाहिए, इसलिए कि फिजिक्स का जो विषय है उसमें मैटर का बात रखें कि मैटर की 3 अवस्था, ठोस, द्रव, हम लोग बच्चे से पढ़ते आ रहे हैं, और उसमें फिर दिया कि प्लाज्मा, और प्लाज्मा अब नया भी आया। और ये जो ठोस होता है, विश्वविद्यालय भी यदि ठोस हो रहा है तो उसके बीच में जो गैप है, उस गैप को भरने का काम यहाँ पर प्रतिकुलपति महोदया डॉली सिन्हा जी और कुलपति महोदय जी ने किया है। हम लोग उसमें सहयोगी बने। ये कार्यक्रम सफल हो, इसी कामना के साथ मैं अपनी बातों पर विराम देता हूँ। धन्यवाद।
Thank you, sir. I think we should laugh at this time. So now we are going to jokes like in Maithili language. अहाँ सब जाने छी कि हम हमर सबके मैथिली भाषा जे छै बहुत बड़ा एक मिथिला के बहुत गौरव बात अछि। तो मैथिली में एगो कहल गेल छै, एगो जोक एक अति हास्यप्रद अछि, जे एगो रामलाल छला, हुनका एगो तोता छलनि। उ तोता बहुत गारि पढ़ि दै छलै, हुनका घर पे जे जाइ छलै ना गारि पढ़ि दै छलैया। एक बेर हुनका घर पे ना पंडित जी एलखिन, तो पंडित जी कहलखिन कि जे मतलब पंडित जी जखने चौखट लग एलखिन कि तोता गारि पढ़ि दै छलैया, आप की करता? तो पंडित जी बहुत गुस्तामस चढ़ि गेलै, कहलकै कि अइयो केहन तोता पोसने छै जे आबिते आबिते गारि पढ़ि देलक। तो फिर बहुत देर के बाद कहलिए, रामलाल कहलिन की कहू पंडित जी, जे आबै छै ना से सबके गाइरे पढ़ि दै छै, हमर से नाक कटि जाइए। तो इसमें पंडित जी बोल के हम अहाँ के एगो विचार दू। तो फिर रामलाल बोले कि हाँ दियो, कोन विचार अछि? तो देखियो ई तोता के हमरा दऽ दिया, ई तोता के ना हम पूरा सिखा देब, पूरा गीता रामायण जते छै अहाँ के तोता बहुत नीक भऽ जायत। तो फिर रामलाल को ई तो बहुत नीक बात कहलहुँ, चलू अहाँ सिखा देब। तो कते दिन लागत यो पंडित जी? तो फिर पंडित जी बोले क्या जो 1 महीना में हम पूरा चीज़ सिखा देब। तो फिर पंडित जी गेलखिन, फिर जब 1 महीना भऽ गेलै तो पंडित जी एलखिन, तो रामलाल को पूछलखिन कि हो पंडित जी पूरा सबटा सीख लेलखिन की? तो पंडित जी कहलखिन कि हाँ सबटा चीज़ सीख लेलथि। तो फिर जब तोता दऽ देलखिन रामलाल के, तो फिर पंडित जी जाए लगलखिन। तो फिर रामलाल को रुकू ई तो बताओ जे हम केना बुझबै कि तोता सब कुछ सीख लेलखिन? तो फिर बाद में बहुत देर के बाद तो फिर कहलिए देखियो तोता के एगो टांग खींचबै तो पूरा गीता कह देता, दोसर टांग खींचब तो पूरा रामायण कह देता। फिर कनी देर बाद सोचला के बाद रामलाल कहै छथिन कि आइयो पंडित जी यदि हम तोता के दुनू टांग खींच लेलिए तब की हेतै? तो फिर तब तोता कहै छै कि साला तब तो गिरिए जाएंगे। Anyway, we have the Dean of Address. We request respected Dean sir to please address the gathering.
Thank you. Respected Pro-Vice Chancellor Dolly Sinha ma'am, Dean Students Welfare Dr. Ashok Kumar Jha, Registrar of this University Dr. Mustaq Ahmad, ex-faculty member of this department who has superannuated from this department, Professor Arun Kumar Misra, the head of the Department of Physics, Professor Arun Kumar Singh, Professor Poonam Tandon, head of the Department of Lucknow, who has joined in this inaugural session for keynote address. The convener of this seminar, Dr. Ritesh Chaurasia ji, deans of different faculties, HODs, teachers, delegates, students, participants, and media person. At the very outset, I would like to say you that this is the last seminar of the first round series of science faculty. Starting from Department of Botany, then Zoology, then Mathematics, then Chemistry, and we reach here in the Department of Physics. This is the first round series of seminars. So I congratulate all the head of the departments. I thank all the head of the departments who have taken initiative and organized such beautiful seminars on different relevant topics in the science faculty. I again congratulate and thanks the Department of Physics, especially the head of the department and the convener who had chosen a very relevant topic for this e-seminar. Dear friends, this conference, Cutting Edges in Material Science, provides an overview of interdisciplinary nature to the scientists and young researchers moving into the boundaries of physics with other applied sciences. This will also provide an opportunity to have an exposure to new ideas and concepts in the field of energy conversion and storage, drug discovery and delivery, micro and macro materials, eco-friendly and biomaterials, etc. We all are aware with the advancing field of nanomaterials. Material science is a discipline which deals with materials from macro to nano scale. It includes electronic materials, biomaterials, high temperature materials, magnetic materials, etc. Each of these deals to improve modern technology and human livelihood. Well, in material science, there is a little something for everyone. I would like to focus some of the key areas in material science, such as a very important key area is graphene. A 2D electrode of carbon is perhaps the greatest thing to happen in the world of material science. High performance lithium ion batteries, water desalination, purification, dye sensitized solar cells, medical diagnostics, graphene has taken the world by storm. There is a lot of scope going ahead into the future. Another key area is semiconductors. If we take example of solid state lighting, we can see for years red and green LEDs were extensively used. One key ingredient was missing for quite a long period. While that is the blue LED, without the blue LED, we could not make white LED because red LED plus green LED plus blue LED is equal to white LED. Now we have also up converting semiconductors nanoparticles replacing toxic fluorescent dyes used in medical imaging. We have high efficiency nanocomposites, cheaper nanostructural superconductor with enhanced electrical, optical and magnetic properties, which are replacing bulk materials applied since long. The next key area is biomaterials. There is several interdisciplinary fields of research such as nanobiotechnology, biophysics, biophotonics, nanobiophotoonics, etc., each having immense potential. Researchers are underway for the early detection of cancer, targeting and destroying malignant tumors. Nuclear materials is also one of the important key area of material science. This is an emerging field of research for material applications in the production of nuclear energy. Several new and improvised materials are employed in reactors. Institutes like Bhabha Atomic Research Center have dedicated departments on nuclear nanotechnology, which too is a really interesting and fairly new area of applied material science in India. I thank Department of Physics for choosing such a nice topic for this seminar. So I am going to sign off here by quoting a line written by Goswami Tulsidas. Goswami Tulsidas has written, "Sakal padarth ehi jag mahi, karma heen nar pavat nahi." Every materials is with us. Sakal padarth ehi jag mahi, karma heen nar pavat nahi. So it is time to awake. It is utho, jago. जितने पदार्थ हमें मिले हैं प्रकृति के द्वारा, जितने हमको प्राप्त हुआ है, उससे नई दुनिया बनाओ, नए उपचार लाओ, नए काम करो। मैं आज बहुत ही खुश हूँ क्योंकि इससे पहले केमिस्ट्री का सेमिनार था। केमिस्ट्री के हमारे डिपार्टमेंट्स के लोगों ने मेहनत की, मैं कहूँ तो जी जान से मेहनत की सेमिनार को एक अच्छा रूप देने की। और जब सेमिनार से मैडम प्रोवीसी निकल रही थी तो मुझे याद आया उनकी एक बात कि अच्छा लग रहा है, सारे लोग आकर के देखे हैं, एक प्रतिस्पर्धा और कंपटीशन की भावना विभाग में जगी। और मैं आज देख रहा हूं, मुझे अत्यंत प्रसन्नता है कि केमिस्ट्री के बाद फिजिक्स ने किया है और इस प्रतिस्पर्धा से मुझे कहने में कतई ये संकोच नहीं हो रहा है कि फिजिक्स बहुत आगे निकल रहा है। अब मैं आशा करता हूं कि मेरा सेकंड राउंड का जो सेमिनार और कॉन्फ्रेंस होगा, नेशनल या इंटरनेशनल, वो इससे भी आगे निकलेगा। हमारे सभी विभाग के शिक्षक विभागाध्यक्ष इसमें कहीं कोताही नहीं रखेंगे और एक इंस्टीट्यूशन के लिए अगर प्रतिस्पर्धा हो जाए विभागों में तो इससे अच्छी बात और क्या हो सकती है। धन्यवाद।
Thank you so much, sir, for the interesting and knowledgeable session. It's been a huge honor to have with us the most honorable A.K. Mishra, sir. With touch feet, we would love to request you to kindly come so that we can have wisdom words and learn something new.
Madam Dolly Sinha, Pro Vice Chancellor, Mithila University, Professor Ratan Kumar Chaudhary, Dean Science, Professor Ashok Kumar Jha, Professor Mehta, my dear friend Brajmohan Jhaji, Sachida Babu, Professor Mustaq Ahmad, Registrar, and the dignitaries on and off this dais. If I have failed to mention any names, please forgive me. But to cut a long story short, I want to come to the topic straight away. It is a very good feeling to be here after a long time. And Professor Arun Kumar Singh and his entire team has done a wonderful work. They have arranged a seminar, and this tradition should continue. When Madam Dolly Sinha took over as Pro Vice Chancellor, I knew some scientific activity is around the corner, and physics department did not take too long to organize such a seminar. And the vision of Professor Singh is very clear. He has invited all the office bearers, all these administration people, all the people occupying administrative posts here, so that when research work starts here, there will be no roadblocks. Professor Mustaq Sahab has assured every one of you that there will be no red tapeism. I want to tell you that previously when projects were sanctioned to this department, the projects did not take off. The entire money was returned. If you want to do something here, you will have to cooperate with the teachers. And Mithila region is very rich in human resources. So if the administration and the teaching faculty goes hand in hand, I am very sure Mithila will go a long way. I don't want to waste any time because you are already running short of time. I bless the students community here, and I am very sure they will give a good account of themselves if they are given proper opportunities. And I think with people like the present Vice Chancellor and Pro Vice Chancellor, that thing will not be lacking. Thank you.
Thank you so much, sir, for so much of grace. I would love to quote, life is a series of natural and spontaneous changes. And with these changes, we have our epitome of expertise and the one who always believes in innovation. Ma'am, we are honored to have you with us. Please, we request you to please come and express your valuable views with us. Give a round of applause for Dolly Sinha, ma'am.
सभी को मेरा नमस्कार and very good morning. On the dais, we have with us Honorable Vice Chancellor of the University, Professor Surendra Pratap Singh, in absentia, the Dean, Faculty of Science, Professor Ratan Kumar Chaudhary, former Professor and Head of the Department of Physics, Ellen Mithila University, Professor A.K. Mishra, sir, the dynamic Registrar of the University, Professor Mustaq Ahmad, Dean of Students Welfare, Dr. A.K. Jha, the Head of the Department of Physics, Dr. A.K. Singh, the convener of this program, Dr. Ritesh Chaurasia, and in the audience also, we have distinguished personalities, the members of Senate and Syndicate, the deans, head of the departments, faculty members, principals and teachers from various colleges, media personnel, and my dear students. Today is a very special day, as some of you must be knowing that 11th of February has been declared by United Nations in the year 2015 as the Day of Women and Girls in Science. So on this very special day, I have brought a picture for you In the picture, you can see Madame Curie, undisputably the greatest woman scientist till today. She has won Nobel Prize twice. Very few persons have got Nobel Prize twice, and being a woman and working those days, it is a great achievement. And there are some bicycles also there. You can see Madame Curie with a bicycle, and there are some, we'll come to that later on. So on this special day, I find two young girls with me here, and they are obviously they are doing MSc in physics, I suppose. So all the girls and women with science, I extend my heartiest congratulations on this very special day to all of you. Now, coming to the subject, I congratulate the Department of Physics under the guidance of Professor A.K. Singh and the convener of the program, Ritesh Chaurasia, and the whole team for choosing this wonderful topic. Materials, as we all know, that they have immense importance. Ancient man first found and began using native metals approximately 7,000 years before Christ. The development of civilization has relied heavily on the discovery of metals. Prehistoric man used metals to build tools and weapons. Even before the systematic study of metals and metal alloys came in, materials were a resource that caused the rise and fall of empires. Those who first made use of new metals, such as bronze or iron, dominated their neighbors. Gold, copper, silver are considered to be the metals of antiquity. These are the metals upon which civilization was based. Earlier metals and their alloys, predominantly bronze, was commonly used to create weapons, ornaments, and fittings of chariots, and also in ship construction by the ancient Greeks and Romans. The discovery of smelting led to the start of the Iron Age, and iron being used for making tools and weapons. The Bronze Age finally gave in to the Iron Age around 700 before Christ, as it was much more abundantly available and easier to process into usable grade of metal. As our knowledge of metallurgy has developed, metals have played an essential role in the advancement of economy. We all know that the currencies of the olden days were made up of gold, silver, and copper. Agriculture, transport, arts, and craft, ornaments, all are made of metals. Material science and engineering as a discipline has been started in the universities much later. It is a hugely influential subject without which we could not understand, discover, nor make use of most of the materials around us today. At every step in our living and entertainment, from preparing our food in the kitchen to children's toys, to rocket science, to warfield, we have been using various types of materials. Without material science, there would be no tools, no bicycles, no cars, no aeroplanes, no computers, no smartphones, no knee transplantation, no stent for the blocked arteries of the heart, no dental implant, and most other things we see around us. Someone has rightly said, material science is the branch devoted to the discovery and development of new materials. It is an outgrowth of both physics and chemistry, using the periodic table as its grocery store and the laws of physics as its cookbook, unquote. Materials in its extraction, synthesis, fabrication, device design, and characterization is an interdisciplinary area where all sciences, chemistry, physics, technology, and economics merge. I emphasize economics too. We'll talk about that later on. There are a number of advances in materials that have either changed our lives or are in the process of changing. For example, how do we assess the value of things? For example, the plastic bags. Undeniably, they are a boon for carrying shopping items, but now also an item of scorn for energy and wastage reason. If we talk about the materials of the modern era, as my previous speakers have already mentioned, the most exciting one that comes to my mind is semiconductor and associated electronics. It is absolutely critical to our modern world. Progress in semiconductor processing and advances in material science have gone hand in hand for last 50 years. Each day we are getting more powerful computers, smartphones and TV sets. It has revolutionized communication system all over the world. Not only we are now connected to any corner of the earth, but beyond it throughout the terrestrial space. It has made possible to look into the nook and corner of the space. Moore's law, referring that the number of transistors on a microchip doubles every 2 years, opened up a new science of miniaturization, where the speed and capability of our computers increase every couple of years, though the cost of computers is halved. So we will pay less for a more efficient system. And that is the buzzword or the idea about material science today. We pay less for a more efficient system. So that is the beauty of material science. We have been designing various types of materials nowadays to reduce the cost. And why reducing the cost? Because we are using less material for that. So material science has democratized also the world. Can you say? Any of you can guess through which item? Material science has democratized the whole world through one item, and that is the smartphones, bringing the technology to the poor all over the world. So all of us now keep smartphones in our pocket. It doesn't matter who is rich and who is poor. So that is democracy. And that the material science has done today. And at the forefront of COVID-19, material scientists are forging ahead with biomaterials, nanotechnology, and other materials research to accelerate a solution. When we talk of computers, we must mention the role of giant magnetic resistance, GMR. GMR describes the large change in electrical resistance seen in stacked layers of magnetic and non-magnetic materials when an external magnetic field is altered. And because of this phenomenal magnetic property, the storage of data at the head of the computer read-write system has reduced very much. So there are some path-breaking discoveries in material science during the last century. If somebody asks you what are the 10 most important materials discovered or 10 most important material science research in the last decade or last century, you will be very much puzzled, because every day new materials are coming up. But some of the research in materials are really path-breaking, and one I mentioned, the semiconductor electronics, the giant magnetic resistance, and similarly, there are one very important discovery, and that is carbon fiber-based materials, which are, when we talk about mechanical strength, we think that if we have a very heavy tool, then that would be very efficient. But material science has made that make that wrong now. Now we look for materials which are lightweight and still stronger than a very heavy metal. We can look in the picture, that the diagram of bicycle you can see, and at the center of it there is a bicycle you can see that is made up of carbon reinforced composite fiber, and because of that, that is very light. If you compare it with the conventional bicycle which even Madam Curie used to use, it's very, very light, but strength-wise it is 100 times stronger. Thus, carbon fiber reinforced plastic was used for making bicycle by Lotus Engineering Company first, and one fellow, Chris Broadman, he won the Olympic gold medal by using that plastic bicycle. So there are large number of discoveries and work still going on in the area of material science. But when we talk of material science, the characterization tools are equally important, and one of them being the scanning tunneling microscope, STM. And because of the STM and later on atomic force microscope, AFM, it is now possible that we can look at individual nano entities such as single molecules, how they react to an external stimuli, how they move and dance on a surface, and how they recognize and talk to each other is no longer science fiction. Moreover, these nano tools allow the manipulation of individual nano objects and enable scientists to gain a quantitative insight into their physical and chemical properties. Thus, they have become crucial in optimizing the performance of nano devices. The first roadmap for nanotechnology is also very important. It was started in USA, as most of the research work nowadays start in USA, but soon all other countries also started working on nanotechnology. For India, it is also very important, because if we talk of micro level growth in material science, particularly microelectronics, it is said that India has missed the bus those days. We don't have the facilities to do research. But when now we are in the era of nanotechnology research, and the government of India also taken up it very seriously, and there are large number of institutions who are working on nanotechnology. And it is a very, very interdisciplinary area. All branches of science, physicists, chemists, biologists, they are working on nanotechnology. Nanomedicine is also a very important branch of material science nowadays. And there is also lots of financing available in this area of research. Now, because there is a great scope and India can contribute a lot in the area of nanotechnology, the Vice Chancellor of our university has also decided that we should focus more on research in this university. And he has, on principle, agreed the next building to this department as to be set up as an advanced research laboratory. So now it is up to you, my dear young teachers and students, that you take up research very seriously. It gives me immense pleasure to find so many students here. They are here to listen to the various aspects of science research in conferences. For about 9 months, the university was devoid of students. Now the students are coming in the university. It's a very pleasant sight when I see so many young students attending a conference. And I find that they are really enjoying such activities. So I wish such programs will be continued, this is not the end, this is just the beginning. About the discoveries in material science, there are large number of discoveries. I don't want to mention all because throughout the day there will be deliberations by delegates, invited speakers, keynote speakers, and I take this opportunity also to particularly extend my appreciation to the keynote speaker today, Professor Poonam Tandon of Lucknow University, and I also thank the Department of Physics that being a very special today, the day of girls and women in science, you have chosen your keynote speaker as lady as one of the speakers. So you deserve appreciation for that too. So madam, on behalf of the university and on my own, I extend my heartfelt gratitude to you for accepting our request and giving your valuable time. I also thank Professor Vijay Raj Singh of Central University of South Bihar for accepting our request, and I understand that throughout the day there will be wonderful discussions on various aspects of cutting edge researches in material science as mentioned by the convener in the beginning, and our students and teachers will be enriched by the deliberations. Material science is a vast area, as I have already mentioned, and some of the areas which will be researched in near future, already research is going on, but the output or the devices have not come yet for our use. These are metamaterials, perovskite cells. You know that perovskites are actually, they are used as ceramic materials which are not yet used for making batteries or cells. They are also being studied because they are very stable material and they can be used for making cells. Then topological insulators, that is also a new field of research area. So there are large number of areas, there is no end to it in material science, and as I said, they are interdisciplinary, and with the help of artificial intelligence and quantum computing over the next decade, the discovery of new materials will further accelerate exponentially like Moore's law. And with these new discoveries, customized materials will grow commonplace. Future knee implants will be personalized to meet the exact needs of each body, both in terms of structure and composition. Though invisible to the naked eye, nanoscale materials will integrate into our everyday lives, seamlessly improving medicine, energy, smart homes, and more. Ultimately, to demonetization and democratization of advanced technologies start with redesigning materials, the invisible enabler and catalyst. Our future depends on the materials we create. Thank you.
Thank you so much, ma'am, for such an informative address and information. Thank you for enlightening us. Thank you for rejuvenating us. Thank you, ma'am. It's been a moment of extreme pleasure and department. She mentioned a term of 9 months. जब एक 9 महीने के टर्म में एक नवजात शिशु का जन्म हो सकता है, तो फिर क्यों नहीं हमारी यूनिवर्सिटी का जीर्णोद्धार होगा आपके आने से। धन्यवाद मैम। Now we would love to request our organizing secretary, Professor Surendra sir, for the vote of thanks.
I deem it a great honor to propose the vote of thanks to all who have helped us in making this seminar such a resounding success. The task assigned to me, that of saying thank you to everyone, is the one that comes with the greatest of responsibilities. The successful completion of this one-day national seminar on cutting edge in material science held today, that is on 11th February 2021 at the University Department of Physics, Ellen Mitla University, Darbhanga, has been a result of the collective efforts of everyone present here in this room. To begin with, I would like to especially thank our dynamic man with a vision, always ready to contribute, Honorable Vice Chancellor, Professor S.P. Singh sir, for giving us his kind consent to host this national seminar. The guidance of Honorable sir has been nothing less than a blessing for all of us at the department. Seizing this opportunity, I would now thank our very resourceful and supportive Pro Vice Chancellor, Ma'am Professor Dolly Sinha, for her important suggestions and guidance time to time. I thank our Dean Science, Dr. Ratan Kumar Chaudhary sir, for his very important contributions. I thank our DSW, Dr. Ashok Kumar Jha sir, for his constant support. Our respected Registrar sir, I thank you for sharing with us your important time. I would like to thank our distinguished speakers, Professor Poonam Tandon, HOD Physics, Lucknow University, UP, and Dr. Vijay Raj Singh, University of South Bihar, Gaya, for making this seminar interesting and meaningful. I would also like to thank distinguished guests and dignitaries, respected deans, heads from various departments, principals from different colleges, retired teachers from this department, learning college members, various faculties, my colleagues at the Department of Physics, participants either online or offline, research scholars, dynamic personnel from media, my dear students who have been running around doing a lot of things, very supportive staff at the department, ladies and gentlemen, my sincerest greeting to all of you. I, Surendra Kumar, in the capacity of the organizing secretary of this seminar, thank all of you from the core of my heart for being with us in our effort in all possible capacities. I thank everyone whom, due to the humanly limitations of my memory, and more importantly, the time constraint, I could not have mentioned by their names. Your contributions, sirs and ma'ams, are duly acknowledged. Thank you for listening. God guide us all. Thank you. Thank you very much.
Thank you so much, sir. We would now request our Pro VC ma'am to give us permission for the end of inaugural session. Ant hi arambh hai, and this ending remarks the beginning of new era of learning. Yes, sir. We solicit permission before the ending of inaugural session. We have a visit to our physics exhibition hall, hands on the top table demonstration and poster presentation by our PG students, and afterwards we go to high.
जी सर। अरे वाह। अरे भैया तू कल हटाइए हटाइए कुर्सी पर इधर बैठिए इधर बैठिए
हेलो, ये डिस्प्ले बंद है, आवाज़ भी बंद है। स्क्रीन पे डिस्प्ले और साउंड दोनों बंद है।
हेलो सर, गुड मॉर्निंग। ये बंद है डिस्प्ले भी, कुछ नहीं आ रहा है और आवाज़ भी नहीं आ रहा है। सिर्फ यूनिवर्सिटी का लोगो आ रहा है।
सर नेक्स्ट सेशन विल बी 12:45। हेलो
हेलो,
हाँ, नेक्स्ट सेशन इज 12:45 PM स्टार्ट।
ठीक है, ओके।
12:45, ओके।
टाइम कितना हो रहा है? टाइम हाँ, 2-3 मिनट में।
चार्ज में लगा तो इतनी जब बकबक करेगा तो आ जाएगा। बात तो कैसे हो?
पैंतालीस का टाइम डाल दिए। 930 और फोन को कॉल कर
म्यूजिक में हम अपने नहीं करेंगे कितने की कर रहे हैं हम डिपार्टमेंट भी देखे पड़े बहुत सारा दो का डिपार्टमेंट PhD के परिचय
हमारा तो डिस्टेंस देखे पड़े पूरा यूनिवर्सिटी हाँ जो सैलरी दे तो करो काम कर हाँ
बोलना नंबर
930 4470 नंबर आ रहा होगा तो खोला रहा है
हम स्टेनो का ले ले बुझलो उर्दू वाला से बात लो उर्दू वाला से
नाश्ता कर लो
टेक योर सीट। वो हमारा ओरल सेकंड ठीक है। और पेन ड्राइव यहाँ लगेगा, पेन ड्राइव इसमें लगेगा। जो पूरे नहीं पहले 3-2 खत्म होगा। हाँ नहीं विजय रत्न 2 बजे के बाद देंगे। ये अमित सर को लेंगे, अमित सर ये इसके बाद अरविंद हम लोग कॉल करते हैं। कैसे कॉल करना है?
किनका कॉल है?
अरविंद लाल
ऑनलाइन है, शेयर किए हुए हैं। जाइए ना वहाँ पर, बोलिए ना, मैं पोडियम पर जाइए ना। वहाँ पानी बोतल उठा लाई दो।
I would like to request you everyone, participants as well as presenters, please come in the seminar room. We are going to start our next session, which is technical session 1, with the invited talk first by Dr. Arvind Lal sir. Sir, are you there? Dr. Arvind Lal sir, are you there? We are ready to. Dr. Arvind Lal sir.
Mute में
Hello.
Yes.
Dr. Arvind Lal sir, are you there?
हाँ sir.
Okay sir, please start. We are here to. Hello sir, we are here to listen you. Please start your talk.
Okay sir, your.
Thank you so much sir.
Appeared or not, sir?
Yeah, we are. You are audible. Yes, you.
Yes sir.
Yes, you can start. You are audible.
Okay sir, good morning to all of you. I am Dr. Arvind Lal, Assistant Professor at Central University of Jharkhand. So my research topic is the study of alkali catalyzed Karanjovai as a potential resource for the biodiesel production. Sir, can you hear me?
Yes sir, you are audible.
Hello.
Yes sir, you are audible.
Hello.
Yes sir, you are audible. Lal sir, you are audible.
हाँ sir, can you hear me sir?
Yes sir, you are audible.
Yes sir.
Present your PPT sir, please. Please share your screen sir with us.
Okay sir, just to give the another persons, then I will.
क्यों फोन कर रहे थे? सुनिए ना। 2 बजे चलो, कितने चलो?
वाला अपने में डालिएगा, ठीक है? टेंशन से तो अपना में डालिएगा। लैपटॉप दे दिए उनको। सुनिए, लैपटॉप पर उठा लो।
After certain temperatures, certain collisions, and it will be fed will be separated. Crude biodiesel बनता है, इसका जब हम फिर वॉशिंग करते हैं, वॉशिंग करने के बाद रिफाइनिंग करते हैं, तो ये बायोडीजल बना। और इसमें क्रूड ग्लिसरीन दैट इज द बाई प्रोडक्ट दैट कैन बी यूज फॉर दी another cosmetic tinters and others medicinal point. तो इसलिए वेस्टेज, इसमें जो हम वॉश करते हैं, वॉश का जो पानी भी होता है, इसमें जो है क्योंकि एल्कली होता है, इससे जो है क्लीनिंग जो है वायली एरिया जो है दैट कैन बी इजीली क्लीन। तो आफ्टर जो है इसके ट्रीटमेंट दैट कैन बी discarded on the atmosphere. So the whole system is environmental friendly system. So how we can make the biodiesel, that can be easily understand with the chemical reactions. This is the triglyceride. Here long chain fatty, different type of fatty acid is there. R1, R2 and R3 is there. Then it reacts with the alcohol, that is ethanol and KOH, and the phase is separated. Two phases separated, upper portions that is the biodiesel and lower portion that is the crude distillate. So these are the R1, R2 and this is indicate the fatty acid can associated with oil and it will vary from oil to oil. इसकी जो प्रॉपर्टी अगर हम कंपेयर करें तो IS बायोडीजल का जो है फैटी एसिड और मिथाइल एस्टर, इसकी डेंसिटी, इसकी विस्कोसिटी लेस देन 6 होता है, फ्लैश पॉइंट 120 मिनिमम है, टोटल सल्फर जो है 50 मिलीग्राम। तो दीज आर द स्पेसिफिकेशंस मेड फॉर द IS। तो इस स्पेसिफिकेशंस को जो मीट करेगा उसी को हम बायोडीजल कहेंगे। अदरवाइज वेजिटेबल ऑयल, और जो मैंने पहले बताया है कि अमेरिका में एक कॉन्सेप्ट है कि उसी को हम क्वालिटी बायोडीजल कहेंगे। इसको जो है वो BQ 9000 लेबोरेटरी से, अदरवाइज किसी सिंपल वेजिटेबल ऑयल अगर उसको हम यूज करते हैं तो आफ्टर सर्टेन टाइम्स, सर्टेन ड्यूरेशंस जो है वो प्रॉब्लम्स, इंजन में प्रॉब्लम्स होगा, उसकी टॉक्सिसिटी वैल्यू बढ़ जाएगी, उसकी ड्रॉप हो जाएगा, जो कैलोरीफिक वैल्यू है वो जो हमको वो नहीं मिल पाएगा, और ओवरऑल जो है इंजन की परफॉर्मेंस। तो इंडिया में अभी भी बायोडीजल का जो व्हीकल्स है बहुत ज़्यादा प्रोपोगेट नहीं हुआ आ रहा है। इसका कारण है कि क्वालिटी बायोडीजल को हम लोग यूज नहीं कर पा रहे, नहीं बना पा रहे। तो कैसे बायोडीजल की क्वालिटी को हम लोग बना पाएंगे, इसके लिए जो है स्पेसिफिकेशन प्रोसेस वेरिएबल्स है। इसमें कंडीशनिंग ऑफ वेजिटेबल ऑयल करना है, वेजिटेबल ऑयल पे क्या क्वालिटी है, उसकी कितने टेम्परेचर पर करना है। अगर सपोज कीजिए कि मॉइस्चर ऑयल है तो फर्स्ट ऑफ ऑल ऑयल को हम 110 पर जो है हीट कर देंगे ताकि मॉइस्चर इवेपोरेट कर जाए, और तब बायोडीजल नहीं, तो इसमें क्या होगा, सल्फिफिकेशन रिएक्शन हो जाएगा और मेरा जो क्वालिटी बायोडीजल नहीं बनेगा। रिएक्शन टेम्परेचर भी कितनी रिएक्शंस पर जो है, कितनी टेम्परेचर्स पर जो है हमको मिथॉक्साइड को मिक्स करना है, सॉल्यूशंस को रिएक्शंस के लिए अप्रूव करना है। इसके बाद कितना अल्कोहल लगेगा। अल्कोहल जो है फेस सेपरेशंस में जो है सहायता करता है। मिथानॉल, इस हम लेबोरेटरी में मिथानॉल का प्रयोग करते हैं क्योंकि इसमें बल्कि ग्रुप कम है, इससे इजीली फेस का सेपरेशंस होता है और हिंड्रेंस नहीं होता है, फास्ट रिएक्शन होता है। लेकिन मिथानॉल के बाद अगर इथानॉल, ब्यूटानॉल इधर से करेंगे तो बल्कि ग्रुप बढ़ते जाएगा, तो इट विल हिंड्रेंस द फेस। उसी ढंग से कैटलिस्ट में करना है। हम यहाँ लेबोरेटरी में KOH का प्रयोग इसलिए कर रहे हैं, KOH जो है वो फास्ट जो एल्केली है, फास्ट रिएक्शंस होता है। NOH का भी कर सकते हैं। तो एक लॉट ऑफ रिसर्च हैज बीन डन इन दिस एरिया टू डेवलप द डिफरेंट टाइप ऑफ कैटलिस्ट। तो ये केमिस्ट्री डिपार्टमेंट इसमें काम कर रहे हैं, कैटलिस्ट पर डिफरेंट टाइप का कैटलिस्ट करना है ताकि जो है फेस सेपरेशन अच्छा हो, यील्ड मेरा अच्छा बने, यील्ड ज़्यादा बने और क्वालिटी पाए। उसके बाद इंटेंसिटी ऑफ मिक्सिंग में कैसे आवर्स को जो है हम रिड्यूस मिनट्स में कर सकते हैं, कैसे रिएक्शंस फास्ट हो। उसके बाद उसके रिएक्टेंट, क्या क्या रिएक्टेंट हम यूज करते हैं उस पर भी ध्यान देना पड़ेगा कि प्योरिटी ऑफ होगा। न्यूट्रलाइजेशन, ग्लिसरीन न्यूट्रलाइजेशन, इसमें जो बाय प्रोडक्ट ग्लिसरीन बनता है और टोटल का टोटल सेपरेट होना चाहिए। नहीं तो क्या होगा कि आपके इंजन के नोजल को ब्लॉक करते हैं। इंजन के नोजल को जो ही ब्लॉक करेगा तो कंबंशन चैम्बर में जो एग्जैक्ट एंगल, एग्जैक्ट होना है फ्यूल्स को, वो नहीं हो पाएगा और जितनी भी हमको जो स्ट्रेंथ चाहिए, एनर्जी चाहिए और जो चाहिए वो नहीं। उसी रंग से मिथाइल एस्टर वॉश, इसमें क्योंकि एल्केली है तो इसको टोटल का टोटल वॉश करके प्योर होना चाहिए, अदरवाइज कोरोजन प्रॉब्लम ज़्यादा हो जाएगा। एल्केली होने से कोरोजन प्रॉब्लम ज़्यादा होगी, इसलिए टोटल का टोटल सेपरेट हो जाना चाहिए। और अंत में जो है रिमूवल ऑफ ऑयल, वाटर, तो इसमें क्या है कि पानी अगर मिक्स रहेगा तो आपका स्लज बना देगा, इसलिए जब वॉश करते हैं तो टोटल पानी तो रिमूव करना है। इसको हम कैसे रिमूव करते हैं, तो बायोडीजल बनने के बाद उसकी विस्कोसिटी चेक कर लेते हैं, उसकी डेंसिटी चेक कर लेते हैं और इसको जो है ओवन में हम 110 पर जो है हीट कर देते हैं। तो इससे जो मॉइस्चर होगा वो हो जाएगा और उसके बाद इसका जो है हम लोग डेंसिटी। तो ये जो लैब हम सेटअप किए थे जब मैं इरनी में था, इंडियन रेलवे इंस्टीट्यूट ऑफ मैकेनिकल इंजीनियरिंग, दैट इज सिचुएटेड इन जमालपुर, where the high officers, only those for railway officers and supervisors that will be trained there. This is the unique institute there. I was the faculty there. We have set up this lab here. There is a steering system, there is a heating system, there is a separating panels, and this is the indicator RPM. So we can increase or decrease the RPM. Similarly, we can increase or decrease the temperature, and that is the control temperature. But in case of my experiment, we have choose the 60-degree temperature. That is the most suitable temperature because we have used the methanol, and after that temperature, if we go for that temperature, 65 is the boiling point, so methanol will be escaped. So there is a problem for the quality biodiesel and conversion of the state. So we can use this equipment there for the conversion of biodiesel. This is the separating of the gasoline with the biodiesel, and after checking the density, we can just go for the other testing. So fuel properties, इसमें जो है हम लोग जो करंजा ऑयल और बायोडीजल को बनाए हैं उसका ब्लेंड करनी है 20% का मतलब है कि 20% बायोडीजल और रिमेनिंग 80 जो है वो आपका HSB है। तो ब्लेंडिंग क्यों करनी जरूरत पड़ी, क्यों तो ब्लेंडिंग को क्यों नहीं हम नीट ऑयल कर सकते हैं, नीट बायोडीजल कर सकते हैं। फिर एक तो इंडिया अभी अवेलेबिलिटी नहीं है और क्योंकि हम लोग जो ईटेबल ऑयल है 80% इम्पोर्ट करते हैं, तो इसलिए क्या है कि इंडिया में जो है ईटेबल ऑयल को जस्टिफाइड नहीं है कि उसको हम बायोडीजल नहीं करें। इसलिए इंडिया में क्या कहा है कि कॉन्सेप्ट है कि वी कैन यूज ओनली दूध नॉन ईटेबल ऑयल इजीली अवेलेबल, लोकली अवेलेबल। तो इसमें हमने B20, 40 और 60 का ब्लेंड करके और उसको स्पेसिफिकेशन जो है बायोडीजल का जो 1560 से और HSB ऑयल का उसके साथ है जो कि टेबलर फॉर्म में है। और इसमें हम देखे हैं कि जो आपका जो रॉ वेजिटेबल ऑयल था, करंट जो ऑयल था, उसकी जो वेस्टिसिटी थी 10.7 times at 40 degree centigrade.
Dr. Ranveer sir, can you hear me?
After purification जो है इसकी विस्कोसिटी
Dr. Ranveer sir,
एंड अदर इसको केमिकल प्रॉपर्टी जो है वो भी इम्प्रूव कर जाती है।
Dr. Ranveer sir,
तो ये डाटा है कि आपका काइनेटिक विस्कोसीमीटर जो है करंट ऑयल का इतना था, तो स्पेसिफिक ग्रेविटी आफ्टर जो है स्टेरिफिकेशन इसकी
Dr. Ranveer sir,
रिड्यूस आ सकता है।
can you hear me?
तो मोटा
Dr. Ranveer sir,
उसको हमने पतला कर दिया, उसकी विस्कोसिटी इम्प्रूव हो गई, उसकी कैलोरीफिक वैल्यू जो है HSB ऑयल की ज़्यादा होती है लेकिन आपका बायोडीजल की कम होती है। लेकिन ये upon the vegetable oil to vegetable, इस टाइम से फ्लैश पॉइंट 287 हो गया। तो फ्लैश पॉइंट हायर इन, तो इससे क्या होता है कि शायद जो है चांसेस की कम है और इसके कम होती है।
Dr. Ranveer sir, sorry to interrupt you, Mr. Dr. Ranveer sir, your time is over, so kindly conclude your session. Any question from audience or any question from audience side? Thanks, Dr. Ranveer sir. Our next invitee is Dr. Nitesh Kumar Chaurasia. Dr. Nitesh.
Hello. Am I audible?
Yeah. Dr. Nidhi sir, can you hear me?
Yeah, fine. So, ID is okay? Hello. So, my slide is visible?
Yeah.
Yes, sir, your slide is visible.
Okay. So, thank you so much for organizing the meeting and respected convener for inviting me for a talk. I hope this talk will be very beneficial for all of the students and maybe for audience. So, my talk is on title entitled Dielectric Semiconductor Interfacial Feed Opening, a new technique to fabricate solution process high performance 1 volt and polar oxide transistor. So myself, Dr. Nitesh, a postdoctoral fellow from Indian Institute of Science, Bangalore. So before going to deliver talk on that topic, I would like to introduce some part for better understanding. So what is the transistor? So transistor was first recognized by R.K. Laboratory in 1962. So transistor is basically a thin film transistor having three main components. One is dielectric layer, where we are seeing the polarization phenomena. After that, a semiconductor layer, and finally this source and drain electrode. Two electrodes, there is source and drain electrode. Thin film transistor is also known as a field effect transistor, because if we applied field charge carrier, we can separate the charge carrier. So dielectric is the main part of any thin film transistor, and its working phenomena is similar to the parallel plate capacitor. So in the absence of any electric field, the charge carrier is randomly oriented, and after applied electric field, they are oriented in a particular direction. So there are two types of characteristics of any thin film transistor. One is output characteristic, where this is the variation of ID, that is drain current with respect to drain voltage at constant gate voltage. That is the variation of ID with respect to VD at constant V. So here in output characteristics, we can see the two things. One is linear region. This linear is known as linear region, and this region is known as saturation region. So for ideal transistor, we are getting the both type of region. And another characteristic is transfer characteristic. This is the variation of ID with respect to VG at constant heat. So all the important parameters of any thin film transistor can be calculated by this transfer characteristic. For example, we measure the efficiency of charge carrier transportation in the device, and it can be calculated by ID equal to mu c W by 2S VG minus VT power 2, where ID is drain current, U is mobility, C is capacitance of dielectric, W is channel width, L is channel length, VG is gate voltage, and Vg is threshold voltage. And main important parameter is on-off ratio. So it defines as the ratio of highest current to lowest current. For ideal transistor, the on-off ratio should be greater than 10 to the power 4, and for higher on-off ratio signifies that the switching speed and device performance. And finally, we can calculate threshold range. This is the inverse slope of transfer characteristics, and finally maximum density of surface state. So, depend on the polarity of charge carrier, we can characterize the transistor in three main types. One is N-channel CFT, where the majority charge carrier are electron, and another is P-channel CFT, where the majority charge carrier are hole carrier present at the same time, which depend on the applied gate bias. So, why we need the transistor? Because transistor has a very vast application in different areas. For example, light emitting transistor for flat panel display, active matrix backplane with oxide CFT, flexible, stretchable, and wearable electronics, biological and chemical sensor based on CFT. So in modern era, we obviously uses our smartphone, tablet, laptop, etc. So in all that application, transistor involved. So as I already discussed, dielectric is the main part of any thin film transistor. So we are very lucky that silicon dioxide is a matchless gift from nature in our MOSFET society, which has property is ideal gate dielectric. For example, it has a very larger band gap, outstanding silicon dioxide interface, high crystallization temperature, high electrical resistance, etc. But at the same time, it has a very low dielectric constant, and due to this, when we operate any transistor based on SiO2, it has a very high operating voltage, high power consumption, at the same time high leakage current. So it is very necessary to replace this SiO2 with some other dielectric which has a very low operating voltage. So Hafnia HF40 was the first dielectric which was replaced by SiO2 in 2007 by Intel 45 nanometer 427 quad-core processor. So why we need high capacitance? Because as we know, if we have high capacitance voltage are inversely proportional. So high capacitance means our operating voltage will be low. At the same time, power consumption will be less, drain current will be high, and low leakage current. So this is the variation of energy gap between the static dielectric constant. Here we can see that although SiO2 is a very high energy band gap around 9 electron volt, at the same time it has a very low dielectric constant around 0.9. So we need to replace this SiO2 by another dielectric. So solution process oxide material. So alternative is solution process material. Why we need solution process technique? Because solution process technique is easy to handle, large area fabrication space, and very low cost. And it has a very wide application, for example, low power electronic devices, non-display technology, low processing temperature, foldable electronics, large area equipment, and complementary circuits. So by solution process oxide technique, we can synthesize different types of dielectric material. We can take nitride, isopropoxide, fluoride as a solute for precursor preparation, and 2-methoxyethanol, acetonitrile as a solvent. And there are different types of thin film deposition, for example, spin coating, dip coating, drop washing. We can take any one. And finally, this thin film has very vast application in field effect transistor, memory, capacitor, etc. So different types of dielectric material we can synthesize by solution process are like electrolyte dielectric, ion conducting oxide, ion gel, molecule, etc. And at the same time, some ultra thin dielectric. And in different types of dielectric, ion conducting oxide paid more attention. In 2009, Paul et al. Published a paper in Nature where he proposed a new type of dielectric, sodium beta alumina, where sodium ion is free to move in crystal lattice and they provide extra ionic capacitance. And due to this capacitance value is high and the operating voltage is very low. So we are mainly focused to develop different types of ion conducting gate oxide to replace SiO2 for lower operating voltage and high performance. We also know semiconductor is also another main part of any thin film transistor, and we can synthesize different types of semiconductor, for example, indium oxide, indium tin oxide, zinc oxide, etc. using solution process technique. Among them, tin oxide is a very important semiconductor to use in MOSFET society because it has a very high transparent material, wide bandgap material, and at the same time, due to the change in oxygen vacancy, it can work as an N-type material, P-type material, and even ambipolar. So we focus on this semiconductor for our thin film transistor. So before fabricating any device, we take a silicon substrate and we clean that substrate because cleaning is very important parameter. If we make any sample on rough substrate, so leakage current will be high, and same time we are not getting any transistor characteristic. So we take silicon substrate, we dip in HF solution and to remove the unwanted negative oxide. After that, we rinse with DI water and Sonicode with DI water, acetone and isopropyl respectively for 30 minutes each. Finally, we did plasma cleaning. Plasma cleaning is a very important step to achieve high performance because it makes the surface very smooth and feed-hole free. Due to this, we are getting a very low leakage current and very high on-off pressure. So we synthesize two new type of dielectric, ion conducting dielectric, that is lithium indium oxide and lithium gallium oxide. For that, we take a precursor indium nitrate and gallium nitrate and 2-methoxyethanol as a solvent. And for semiconductor, we take tin fluoride as a precursor and 2-methoxyethanol as a solvent. Before going to fabricate our device, we did some electrical measurement to check the quality of dielectric. For that, we did leakage current density and areal capacitance measurement for our two dielectrics, lithium indium oxide, lithium gallium oxide, and we also check with our previously published dielectrics to check the just comparison to our data. Here we can see that in case of LiN2 gate dielectric, we are getting a very low leakage current, and at the same time we are getting a very high areal capacitance. As I discussed earlier, if we are getting a very high capacitance, so our operating voltage will be very low. And you can also see that the operating breakdown voltage is very high, around 16 volts. Here you can see that 16 volts the device got breakage. But our operating voltage is around 2 volts, which is 2 volt or 1 volt, which is approximately 8 times higher than the breakdown voltage. So we can Yet this dialectic is ideal transistor using 3 different types of ion conducting gate dialectic, that is lithium zincate, lithium gallium oxide, and lithium indium oxide. So in three of the dielectric, we are getting a very nice linear and saturation region, but at the same time we can see that in lithium gallium oxide, saturation region is not quite good, but mobility wise with lithium zincate we are getting around 16. In case of lithium gallium we are getting around 0.35, very low, and in case of lithium indium oxide we are getting around 7 centimeters square per second. At the same time, we are getting a very low SS value. SS value also defines the performance of silicon transistor substrate routing, which I already discussed in introduction section. And finally, we need a p-type characteristics. So we are getting again the p-type characteristics in both of our device dielectrics, like LiINO2 and LiGO. Here we can see that p-type characteristics are achieving only in these two dielectrics, but in case of Li202 characteristics, we are not. While we can see that mobility is around 7 and mobility is around 8 in case of LiNO2 gas dialectric. So why we are making such type of ambipolar device? Because it is very necessary to use in CMOS electronics for ambipolar device which has a very balanced mobility, that is N-type mobility and P-type mobility. Here we can see that in case of N-type characteristics with LiNO2 gas dialectric we are getting mobility around 7. At the same time, in case of P-type we are getting mobility around 8. So if we conclude that, finally we gave an application using two ambipolar TFT using LiNO2 gas dialectric. So this is the inverter characteristic. One is the first quadrant and another is the third quadrant, depending upon the bias. So here we are getting a gain is very high, around 30 in first quadrant and around 20 in second quadrant. Due to the very balanced mobility in P-type and N-type. So this is the summary of various parameters. We synthesized two different types of ion conducting gate dielectric, and if we compare, we can see that LiNO2 gate dielectric is processing temperature around 550 degrees centigrade, and it has a very balanced mobility around 8, and at the same time very high on oscillation. So we can use this dielectric in CMOS electronics. So these are the conclusions. Mobility is very high, at the same time gain is very high. So this investigation suggests that a new direction for the development of high performance low voltage ambipolar TFT by selecting proper material combination of gate dielectric. Thank you.
सर यहीं से बोलिए ना, यहाँ से बोलिए, अच्छा कैमरा इधर है, यहाँ बैठ।
Thank you, Dr. Nitesh Kumar Chaurasia.
Yeah.
Any question from audience side? Any question?
Nitesh sir.
Yeah, question. Actually, the student question is not audible. Can you?
TFT full form, sir. TFT.
It's not audible.
ये नीतीश सर ये टीएफटी का फुल फॉर्म बताइए।
Yeah, TFT is basically transistor as in our industry, right? Different transistors basically are these transistor. One is dielectric, one is electrical, another is electric. So you can get it.
Okay, thank you, Nitesh sir.
Any more questions?
Any more question?
Any more question?
Thank you, Dr. Nitesh Kumar Chaurasia. Our next participant. Our next invitee is Dr. Amit Kumar Singh. वो स्क्रीन शेयर कर दे रहे हैं स्क्रीन शेयर। कौन सा है ये ना?
Good afternoon to all of you. First of all, I would like to convey my sincere thanks to all the team members of this conference for inviting me here to deliver an invited talk. It gives me immense pleasure to be present my research work on this dignified platform. And I hope my presentation will be fruitful to all of you. That is exchange bias phenomena in nanostructured magnetic materials. So, next slide please. These are the contents of this particular presentation. First of all, I would like to give you a brief introduction of all the terms that I have used in this presentation, such as nanostructures, magnetic nanostructures, exchange bias phenomena. Previous slides. Previous slide, please. Spin glass phenomena, and then the materials that I have chosen for research work, the double perovskite materials, and then we will discuss about the research work that I have done. In the research work, I have studied exchange bias phenomena in various types of nanostructures. Two types of nanostructure I have used. First is nanoparticles and thin films, and then we will discuss about the applications of this phenomena in the magnetic materials, and then the references. Next slide. Next slide. So basically, nanostructure, nanotechnology is an interesting branch of science in which we can play with the materials. By reducing the size of the materials, we can change the properties of that materials according to the desired application. So nanostructure basically are the structures. Those have at least one dimension should be in the nanoscale range, which is generally considered from 0.1 nanometer to 100 nanometer. There are some types of nanostructure. First, zero-dimensional nanostructure. In this case, electron is confined in all the 3 dimensions. So these are the examples: nanobots and nanoparticles of 0D structure. In case of 1D structures, electron is confined in 2 dimensions, and electron can move freely with only in 1 dimension. In case of 2D nanostructures, electron is confined in the 2 dimension, and it can be moved freely only in 1 dimension. 3D structure basically are considered to be the bulk material. It doesn't fall in the category of nanostructures. Next slide. So our main interest is only in nanoscale thin films. So I want to discuss it in detail. In case of thin films, as you can see here, that electrons can move freely in the 2 dimensions. Those are indicated by 10 centimeter and 10 centimeter range. And electron is confined, or it is localized only in 1 dimension, which is around 10 nanometer thickness. So in case of thin films, electron is confined around the thickness of the film, and electron is free in length and breadth of the film. Next slide. Now the magnetic nanostructure. Basically, when we reduce the size of a bulk magnetic material from its bulk state to nano state, then drastic changes occur in the magnetic properties, like magnetic coating. First of all, magnetic coating. Suppose if magnetic material is ferromagnetic in its bulk state, when we reduce the size of that material, it's transformed to a super paramagnetic, as it is found in the literature. Then second one is the transition temperature. Transition temperature may also enhance or may decrease with reducing the size of the material. Third one is magnetic anisotropy. Basically, magnetic anisotropy is the internal energy of the system. We decide the easy and hard axis of the magnetization. So it is basically a direction dependent property. Some rich and fascinating phenomena are observed in magnetic nanostructure. Giant magnetoresistant, tunnel magnetoresistant, and exchange bias. Next slide. Next slide. Our main interest in exchange bias, so we will discuss only exchange bias in detail. Exchange bias basically it is a phenomena which occurs at the interface of 2 different magnetic phases, like combination of ferromagnetic and anti-ferromagnetic material, or it can be combination of ferromagnetic and spin glass state. It can be the combination of AFM and ferrimagnetic, etc. So this phenomena was discovered in variety of large number of systems such as bilayers, multi-layers, inhomogeneous materials and nanoparticles as well. So this is the basic physics behind the exchange bias phenomena. We will not discuss here because due to the time constraint. Next slide. Next. Spin glass is another fascinating phenomena which is observed in magnetic nanostructure. Basically, spin glass is completely randomness of the ordering of the magnetic ordering. So it is not a magnetic state itself. It is a combination of mixed state of two different magnetic phases. Basically, spin glass is a competing interaction between the ferromagnetic and anti-ferromagnetic spins. So it can be explained by a very simple example, triangular lattice. Here we can see that one spin is in up state and another spin is in down state. So third spin is quite confused. It cannot decide what will be the orientation of this spin. So it is a mixed phase of FM and AFM spin. Next slide. Since I work on the double perovskite material, so I want to give you a brief introduction of double perovskite material. Basically, perovskite is structure related term. So the name of these materials comes from the structure, their structure, which is perovskite. So in case perovskite is having formula AbO3, where B is the transition metal ion and A is the rare earth ion. B atoms form the octahedral with the oxygen atom. When we repeat the when we take two different single perovskite layer unit cell on one another, then it form a double perovskite structure, which is depicted in the third figure. Next slide. I worked on this particular material, Nd2NiM106, which is among all the double perovskite, it is a material. At that time, when I had chosen this material, there was a lot of scope to do more things with this material because this material was less explored at that time. So this is the crystal structure of Nd2NiM106, which is generated by Vesta software. Next. Now, let's start the research work in which I have studied exchange bias phenomena in various types of nanostructure. First of all, exchange bias in Nd2NiM106 nanoparticles. Next slide. Before starting the research work, I want to tell you something about the anti-side disorder. It is an important thing, because anti-side disorders play a vital role in deciding the properties of double perovskite material. They are the natural broad defect. Previous slide. Conclude kar deं. Next slide. Next slide. So I have synthesized nanoparticles using solid state reaction method, and then we studied the properties of these nanoparticles. We found that exchange bias is present in our nanoparticle samples, and after that we have worked on the thin films of the Nd2NiM106 material, and we have also found exchange bias in thin films also. So the observation of exchange bias is indicates that there is a large number of variety of systems where we discovered exchange bias, and which will be helpful in the development of spintronic application. So there is a future scope of exchange in these materials. Then we can construct different type of magnetic nanostructure and can observe exchange bias, which will further lead to these applications in spintronics, field of spintronics.
Thank you, Amit Kumar Singh. Any questions from audience side? Any question from audience side? No.
Okay, fine. Our next invited talk is by Dr. Amit Gupta.
Yeah.
Please. I would like to request you, Dr. Mohammad Tanveer Asraf. Please prepare yourself for next talk.
ये स्लाइड है ना आपका? हेलो.
I would like to give a thanks to the organizer for inviting me on a talk here. Today I will discuss some my previous work.
Dr. Asraf, please mute.
Hello.
Dr. Asraf, please mute your mic.
Hello.
Dr. Asraf, please mute your mic. Be prepared for next talk.
Asraf sir.
Be prepared for next talk. After Amit Gupta. Dr. Amit Gupta. Okay.
Hello.
Dr. Amit Gupta, please start your talk.
First slide.
Where is the
Slide is not coming.
Where is slide?
दे रहे हैं सर. PPT है ना इनका, स्लाइड नहीं है.
हाँ PDF actually.
हाँ तो PPT से PDF स्लाइड दे रहे हैं.
अरुण सर, मैम कहाँ है? 2 बजे. 2 बजे. तो भैया सिंह सर का 3 बजे.
So I would like to thank the organizer for inviting me talk here. So today I will discuss some my previous work, which is on wire semimetals. And so the topic is the title is the novel electric field effects on endowed levels in multi-wire semimetals. So my talk is very technical, and I think if you are familiar with quantum mechanics and second quantization, then you can understand very easily. Otherwise, this is very technical talk, and lots of mathematics are there. So please go to next slides.
Dr. Amit Gupta sir, I would like to request you please make easy for postgraduate students.
I will try to.
Thank you.
So these are this outline. These are some outline of my talk. So we will discuss some these topics. Go to next slide. So this is right. So I will discuss my work. Actually, I had some work on wire semimetals. So if you see there, it is written top 10 breakthrough in 2015. So ये top 10 breakthrough था in 2015 research work. So the physics of the there is some quotation here. The physics of the wire fermions are so strange. There could be
Excuse me.
things that
Excuse me.
that can arise from the particles that we are just not capable of using now. So this is the quotation from Jahir Hassan, who discovered first wire semi-metals, right? Go to next slide. So here now lots of work are going on in this field right now. And, so this wire fermion, if you are familiar with Dirac equations in quantum field theory, so if you take m is equal to 0 massless Dirac fermion, if you take just Dirac equation and put m is equal to 0, you get this wire fermions, right? So and this plus minus represent a chirality. Chirality, I think if you are familiar with quantum field theory, chirality is the direction of spin with its momentum. So if both are in the same direction, then it is positive chirality, and if they are anti-parallel, means opposite direction, they have negative chirality. So there are two kinds of wire fermions, plus chirality and minus chirality. Please go to next slides. These are the Hamiltonian for wire fermions. These are the Dirac equation. You can see m is equal to 0 in equation 1. If you put m is equal to 0, you get basically fermions equation, right? Which I had I had just told in previous slides. Please go to next slides. So this is how to get the wild fermions or wild semi-metals. So you can get by two ways. If you have a Dirac one, Dirac breaking time reversal symmetry first, and second one is by breaking inversion symmetry, right? So right, you can go to next slides. So two ways you can get wild fermions from Dirac semi-metals. So why do we study this wild fermions in condensed matter? Why people are excited about wild semi-metals? Because it provide the realization of wild fermions. These wild semi-metals provide the realization of wild fermions, which Weil has predicted long back in 19th century. And then second is extend the classification of top pressure phases of matter beyond insulators. Because this is the topological phases. Earlier, people have discovered this topological insulator, and that was gapped system. But here we get the topological phases in gapless system. Third, we can get the realization of magnetic monopoles in A space, right? And fourth is it hosts exotic Fermi arc surface states. So this has lots of applications and outcomes of this Fermi arcs. Please go to next slide. Magnetic monopoles it doesn't exist. We learned in MSc course कि दो पोल होंगे, South pole, North pole, but there is no monopole concept. But here we get monopole in a magnetic field, means magnetic monopole like things, right? So because a magnet has two poles, North pole, South pole, we can't get, if you cut the magnet in two pieces or many other pieces, you always get two poles, but you can't get monopoles. But here you can see the magnetic monopoles, right? So this is the realization of monopoles in wild fermions. So these are the Fermi arcs. Okay. The Fermi arcs actually basically these are the projection of these wild points. Okay. If you connect two wild points, so its projection on Brillouin zone, surface Brillouin zone, so it gives rise to Fermi arcs. So go to next slide. It is technical, so it is. It takes lots of time. I would like to go to details for Fermi arcs. So Landau levels in graphene. So this is the MSc course. You might have solved this Landau levels problem. So in graphene, so graphene has Hamiltonian H Bf alpha dot pi. This pi is basically canonical momenta. P plus E. A is vector potential. So we have, if you solve in Landau case, then you can get the these eigen energies and size eigen vectors, right? Go to next slide. So this is the Landau level problem. And now if you put this graphene in electric field, because Landau levels basically forms in presence of a strong magnetic field. But if you apply electric field in perpendicular direction to the magnetic field, so it is called cross electric and magnetic field. So these are the Hamiltonians. We get extra term E capital E into X, where X is the direction of X direction, this position in this place. And if you solve this problem, you get eigenenergies and eigenvalues. And if you see these eigenenergies, there is 1 minus beta square. If you solve this problem, this is the graphene Hamiltonian. But if you put some electric field along S direction, its Hamiltonian has additional term. And if you solve this problem, it can be solved exactly. If you solve, you get the eigenenergies. And here this term is 1 minus beta square, where beta is some electric field ratio upon B of B, right? So if this beta is close to 1, you get E is 0. So this is called Landau level collapse. If you see in previous slides, there is no term like this. You can basically these terms. So there is Landau levels. For every integer, you get basically Landau levels. But if you apply electric field in perpendicular direction to magnetic field, you get your eigenenergies will be modified and you get this additional term, right? And if beta is very close to 1 or equal to 1, so this is 0. So whole Landau levels is collapse. This खत्म हो जाएगा, Landau levels रहेगा नहीं, right? And और ये इसकी eigen's vectors है. So इसको easily solve किया जा सकता है. MSc बच्चे कर सकते हैं. So this is if you familiar with quantum mechanics, you can solve it very easily, right? Next slides. Thank you. Next slides, please. So this is the collapse of Landau levels. Here, if you increase this electric field, you can see these are the Landau levels. At 0 electric field, these are parallel. This is Landau levels. But when you increase the electric field, this Landau levels goes to 0. When this ratio becomes 1, means beta is, this is basically beta. So when beta becomes 1, so more Landau level collapse. Right? This is called the collapse of Landau levels. Now, people have solved quickly graphene first of all. Right? Next slide. This is easy problem, but you should be familiar with basic quantum mechanics. So this multi-wave semi-metals. So multi-wave semi-metals में क्या होता है? Basically here we get cubic dispersion and quadratic dispersion. Right? Here cubic dispersion is there, and this is quadratic dispersion. In wire fermions, all the three momentum component kx, ky, kz are linear. But in multi-wire, you get quadratic and cubic dispersion is there. Right? So our problem is to see the effects of electric and magnetic field in cross direction, whether collapse of Landau levels happen or not. Right? For linear dispersion, people have solved this problem. I had just extend this work for double wire semi-metals and triple wire semi-metals, whether same things will be happen or not. Right? This was my work. Right? Please go to the next slide.
Dear Ravi sir, can you conclude your work?
Okay.
Give the gesture of your.
Just go, because I have solved this problem by using perturbation theory. So if you are no perturbation theory, you can solve this problem very easily.
Yes.
This is a little technical, and I had learned perturbation theory by solving this problem.
Basically,
earlier I had no idea, means not much idea about perturbation theory, but this problem has taught me to solve any problem
basically
like
for newcomers, this is very interesting research topic.
Yeah. So this was my conclusion. इसमें क्या होता है कि this Landau level collapse happen नहीं होगा. If you go in means quadratic or cubic dispersion, there is a partial collapse. क्योंकि अगर linear dispersion है तो वो exactly collapse हो जाएगा when beta goes to 1, right? But अगर आप जाते हैं momentum में cubic quadratic में this never happens. So right, and you can see in quantum oscillation experiment, because we are applying magnetic field, so you can see basically in this effect in quantum oscillation experiment also. So thanks for your kind attention.
Thank you very much, sir. Any query from audience side? Yes, sir. Say.
Sorry.
Any query?
All about the graphene, right?
Please be quick. Mike. Yes.
Yeah, Avinash.
Sir, it
Please
was
be quick,
all about
be
the graphene. We know that it's from the covalent bond and its lattices, the long bonds structures. So during this, when you are describing about the energy, when the electrons are displacing from one level to the another levels, like the so many energy levels you are describing, I want to know that when the electron having their own spin, they have their own configurations, like they having spin quantum numbers, and also the nucleus having their own rotations, due to which they have their own rotations. When the electrons passes through the formations of the graphene, in that condition, sir, electrons is a charge. When they are moving, then it's create the magnetic field, right? And magnetic field, when they are accelerated, then it emits the electromagnetic radiation. That's why we are not using the graphene as a device which can create the light.
No, I use this magnetic field, external magnetic field. Here, this
But
B is the external magnetic field.
But we can create also magnetic field by the moving of the charge inside the conductor. And also I have heard about the carbons, not about the graphenes, that they have the same structures as we have in the DNA. That means when you will be studying about the cell, then you will be studying about the nucleus, and nucleus containing the gene, and genes having their own configuration like the pentagonal and hexagonal bonding, and that bonding, due to that bonding we have the life. Not due to the presence of the nucleus in our cell, we have the life. Why? Because when you will be studying about the nucleus, then you could get the gene and then the DNA. The gene is a structure containing the rough structure that is called the DNA, and DNA is responsible to getting the life. So everything about the life is only the DNA, and DNA containing the same structure as you are provided as the graphene. That means they containing the carbon-carbon bonding and double bonding and triple bonding. So that's why we have a study that when the electrons are passing by through the one level to the another level, that means excited state, then they emit the so many radiations like the hydrogen spectra and many more. So why we could not be develop such a things that we know we have the atoms, we have this one, this is formed by the aldehyde, it having the carbon hydrogen bond and carbon hydrogen containing the electrons. When the electron they have, it means that we can accelerate the electron and we can get the radiation. So we did not need of the sun. We can create the energy itself, not by the means of the external things like when we provide
Conclude yourself. What is the problem?
Sir, my question is one thing about that. Why we are using such a graphene technology? Why we are not we create the light or radiations with the help of this graphene theory, sir?
I'm not getting this.
I'm not getting.
My problem is I had solved this whole thing in the presence of external electric and magnetic fields. And there is not a single electron here. Here we are talking about in bands. There is not a single electron. There are 10 or 23 electrons in the system.
And solve your problem. Your problem is too much long.
And there are not statistics in that sense.
So thank you, Dr. Amit. Thank you, Dr. Amit. Next talk is from Dr. Mohammad Tanveer Ashraf. Tanveer sir, are you there?
Yes.
Please continue yourself, Tanveer sir.
Yes. Thank you.
The topic of
I am very glad to meet. I am presenting the script.
Yes, please continue.
Yes.
Thank you, sir. No, please keep quiet, please. He is from MRM. You have too much time to interact with him. Okay. He's coming here regularly. Most frequently, regularly, most frequently.
Are you able to listen me?
Yes, you are audible. Tanveer sir, please continue.
Yeah. I am Dr. M.B. Tanveer Ashraf from APSN College, Brownie, LNMU University, Darbhanga. I am presenting the recent advancement of chalcogenide nanomaterials. And the presentation here, my presentation, is basically for the research scholars and for those faculty members who are not done their PhD.
Mr. Tanveer sir, I would like to please.
मतलब उनको समर्पित है जो अभी रिसर्च करने जा रहे हैं या रिसर्च कर रहे हैं। तो मैं अपने मटेरियल्स के बारे में उन्हें कुछ बतलाना चाहता हूँ कि नैनो मटेरियल्स में चैल्कोजेनाइड ग्रुप्स के भी नैनो मटेरियल्स बनाए जा रहे हैं जिसके बहुत अहम एप्लीकेशंस हैं। सबसे पहले हम समझेंगे कि चैल्कोजेनाइड्स क्या है। जिस तरह से हैलोजेंस होते हैं, हैलोजेंस आर द एलिमेंट्स, लाइक उसी तरह से चैल्कोजेंस आर द एलिमेंट्स ऑफ ग्रुप 16, sulfur, selenium, beryllium and oxygen. Oxygen is not included in chalcogen. And there is another metal chalcogenide. Metal chalcogenide contains one metal cation and one chalcogen anion. The compound is metal chalcogenide. It is also used for the purpose of making nanomaterials and chalcogen glasses. The glasses containing one or more chalcogen elements like sulfur, selenium, beryllium, etc. There may be one chalcogen element or two or more with metals. This was a brief introduction. Now, what is the key characteristics of such materials? The key characteristics are the materials are semiconductor in nature. They have direct band gap. This is the advantage of this material. They have semiconductor and they have direct band gap. And its quantum dot have a band gap in the range of 1 to 3 electron volt. Hello, are you listening me?
Yes, sir.
Okay,
Sir, please quick, sir. You have a time limit. We are already
Okay,
too much
okay,
late.
I am continuing.
Please be quick, sir. Please be quick.
Yeah. And these materials are high dielectric constants, high transmittance, large bore exciton radius. These are very important key characteristics of such materials. And what are the objectives of choosing such materials in nanoscale? I have written two main objectives. The synthesis of nanostructural materials enhances the properties and the study of influence of morphology, structure and optical properties of nanostructures. The motivations, I have also explained the motivation, size effect on the optical and physical properties and its chemical properties. And one more thing, that the strong varied response to optical, electrical and thermal stimuli. Properties can be tuned by doping of other materials. Optical band gap can be easily tuned by doping with low phonon energies. It is transparent from visible to infrared range.
Tanveer sir, you are stick on the first slide. You have more slides.
It has numerous applications. It can be used for the making of detectors for thermal imaging. It does not require cooling and perform better at low temperature.
Mr. Tanveer sir, I would like to interrupt you.
Photoconductor material. Its detection mechanism based on the change of conductivity with incident photon. It has a numerous application in the solar cells.
Mr. Tanveer sir, your slide is not moving.
Hello?
Your slide is not moving. You are stick on the first slide, introduction slide.
Yeah. Next slide.
Your slide is not moving, sir.
Okay.
Please be quick, sir. We have lot of speakers in this particular session. Please be quick.
The application of such materials are IR detectors, thermal imaging, okay, and sensors, solar cells, photoresistors, and thermoelectric devices, etc. There are various applications from which we can use nanochalcogenides, and we can enhance the efficiency of solar cells and sensors also. Now come to the main theme of the root of the nanoparticle is the quantum dot. Quantum dot behaves itself as an artificial atom. We know that in a bulk form, the band gap is continuous and bands are very continuous, and there is a low band gap and high filling factors are there. But as we reduce the number of items, that is the particle becomes smaller in size, the energy level becomes more discrete in nature, and it has a high filling factor also. Here in the last figure we can see that. I also try to explain the size effect in nano field. As we reduces the size of the particle, we can see that the discreteness in the energy band gap also increases accordingly. That is, we are moving from red to blue. As we move from red to blue, the size of the particle gets reducing. Here, we are showing here the picturization formation of this. Now I am presenting a brief discussion on my published research work. It has been published in the Journal of Alloys and Compound Elsevier. You can see. So I am just discussing.
Tanveer sir, you have a time limit. Please.
Right from materials from its surface morphology and optical studies also.
Please don't
characterize the X-ray diffraction, HR10, and in optical characterization we have characterized UV visible and photoluminescent spectroscopy. So, from XRD analysis,
Tanveer sir, please conclude your talk.
Some peaks are there. These peaks indicate that the material is polycrystalline in nature. Polycrystalline, not crystalline, not amorphous. It is polycrystalline. Okay.
Tanveer sir, please conclude your talk. Please conclude your talk. You have a time limit. I already mentioned.
I am just finishing it. The next parameter of physical parameter is SIM analysis. A scanning electron microscope. We have characterized 4 different samples for different values of x equal to 0, 5, 10 and 20. For x equal to 0, the first pictures we can see that the particle size are bigger. As we add more and more number of doping concentration, the particle gets reducing accordingly. हम लोग यहाँ पे देख सकते हैं कि पिक्चर ए में फिर उससे छोटा पार्टिकल्स बी में है, उससे छोटा सी में और उससे छोटा डी में है. तो जिस तरीके से हम डोपिंग कंसंट्रेशन को बढ़ाते जा रहे हैं, पार्टिकल का साइज रिड्यूस करते चला जा रहा है. और दिस इज द टाइम एनालिसिस. फ्रॉम टाइम एनालिसिस वी आल्सो ऑब्जर्व दैट नैनो पार्टिकल्स आर फाउंड एंड साइज इज अबाउट 20 नैनोमीटर. 20 नैनोमीटर. We can write it is a cubical in shape also. And this is time histogram basis. On the basis of time and unit analysis, we have just drawn a histogram for explaining the size of the particles. हम लोग यहाँ पे देख रहे हैं कि 15 से 20 नैनोमीटर के साइज में बहुत ज़्यादा पार्टिकल्स यहाँ पे हैं. आप देख सकते हैं. और ज़्यादातर पार्टिकल जो है वो 3 से 25 नैनोमीटर के रेंज में, अबाउट 70% पार्टिकल जो है वो 3 से 25 नैनोमीटर के रेंज में पाए जा रहे हैं. इसका मतलब कि बहुत अच्छा रिजल्ट आ रहा है. अगर हम इसमें इंडियम को डोप करते हैं लेड सेलेनाइड में, तो हमारा काफ़ी बढ़िया रिजल्ट यहाँ पे आ रहा है. उसी मटेरियल का हमने ऑप्टिकल स्टडीज भी स्टडी किया है. PL emission spectra is there for different amount of indium. For x equal to 0, no indium. For x equal to 5, 10 and 20, we have increased the amount of indium gradually from 0 to 20. So, with the variation of indium concentration on EPSP material, we are observing 4 different characteristics here. The characteristics shifted from red to blue. This is called blue shift. Blue shift is there, and the quantum dots of this sample has been excited at 300 nanometer, and emission was absorbed at 370 nanometer. Blue shift is observed.
Tanveer sir, please conclude yourself. Actually, we have lot of postgraduate students.
Okay.
And research scholars are well known about. Yes sir. Yes. I would like to request you, sir. Please.
This is the scope and future plan. The synthesis materials can have application in the field of solar cells, sensors, thermoelectric generator, cooling unit. मतलब कहने का है कि इसमें बहुत ज़्यादा एप्लीकेशन है. अगर हम लोग लेड सेलेनाइड या चैल्कोजेनाइड ग्रुप पे रिसर्च करते हैं, तो बहुत कुछ चैल्कोनाइड से होना बाकी है. अगर हम स्टडी करें चैल्कोजेनाइड की, तो बहुत सारे एप्लीकेशन हम इससे बना सकते हैं, और बहुत अच्छा रिसर्च अभी चल भी रहा है. तो काफ़ी अपॉर्चुनिटीज़ है चैल्कोजेनाइड्स पे. हमें इस पे फोकस करना चाहिए, हमें स्टडी करना चाहिए, लिटरेचर सर्वे करना चाहिए चैल्कोजेनाइड्स पे. थैंक यू.
Thank you sir. Thank you Tanveer sir for your nice talk. Any
शॉर्ट
question?
में थोड़ा सा ब्रीफ इंट्रोडक्शन ही दिया है इसमें कि मैंने एक्चुअली इसको फोकस किया इस प्रेजेंटेशन को स्टूडेंटली पर्टिकुलरली हमने रिसर्च स्कॉलर्स के लिए किया और उन लोगों के लिए जो अभी रिसर्च में कदम रखना चाहते हैं, तो उनके लिए मैंने ये प्रेजेंटेशन तैयार किया है कि वो इस चीज इस फील्ड को
Thank you, Tanvir sir, from Research Scholar side. Thank you so much for your nice informative talk. Thank you so
बहुत ज्यादा कॉम्प्लिकेटेड और टेक्निकल नहीं बनाया, क्योंकि टीचरों को सब पता है, वो जानते हैं, वो हमसे ज्यादा जानते हैं, इसलिए मैंने स्टूडेंट्स बस इसको डिजाइन किया था कि उनको इन फील्ड्स की जानकारी। थैंक यू सो मच।
Thank you sir, thank you so much.
Everybody. Thank you.
I would like to request you, Mr. Utkarsh Pandey. Are you audible? Mr. Utkarsh Pandey from IIT BHU. Utkarsh Pandey, are you audible? Miss Neela Pal, are you audible?
Yeah, sir, I am here.
Please continue, Neela. Please continue.
Okay, just a minute.
Neela
I'm just
Pal is from
presenting.
School of Material Science and Technology, and her topic is a solution process metal oxide thin film transistor. Please continue, Neela.
Just a second. I'm sharing my screen.
You have a time limit, Neela. Please be in.
Okay, sir.
Okay.
Okay, sir.
Please be continue.
Yeah. Good afternoon, everyone. I am Neela Pal, and I am currently pursuing my PhD under the supervision of Dr. Bholanath Pal. I am from IIT BHU. Just a second. And thank you for giving me the opportunity. And today I am going to present on the topic solution process metal oxide thin film transistor with ion conducting gate dielectric and its application in colloidal PBS quantum dots heterostructure phototransistor fabrication with asymmetric source drain electrode. So outlines of my presentation are introduction, brief description of device, experimental result and discussion, conclusion and references. So in introduction we will briefly talk about what is the thin film transistor. As we know, we are now in this era, we are mainly we have various application in electronic gadgets like in display as well as in mobile phone, in sensor and other. So thin film transistor is heart of this technology. Here it is a three-terminal device with a drain, source and gate electrode where dielectric is sandwiched between semiconductor and gate electrode. And if we put some voltage in gate electrode, the dielectric will be polarized as well as accumulation of charge in the semiconductor layer. As a result, a conduction path will be formed and the current will flow from drain to source region. The main or the typical characteristics of the transistor are of two types. One is output characteristics shown in figure 1A. Figure A, where you can here the gate voltage is kept constant and the drain voltage is varied, and you can see that it has two distinguished region. One is linear region and another is saturation region. And all the key parameters of the thin film transistor like field effect, mobility, ion-off ratio, subthreshold swing and threshold voltage are extracted from the transfer characteristics, where the drain voltage, drain to source voltage is kept constant and the gate voltage is varies. So the switching speed of the thin film transistor is determined by its field effect mobility, and ion-off ratio is how it is working as a switch, like off means light off and on means light on. So where the and another application of a transistor is a phototransistor. What is a phototransistor? It is basically a thin film transistor where the active layer is a photosensitive material. So when we illuminate it, electron due to the illumination The photon will create electron hole pair, and this will be extracted in source and red electrode. Here we can see the characteristics that in red one is in dark condition and another are in illuminated condition. The key parameters of a phototransistor is photosensitivity, external quantum efficiency, specific detectivity and response time, which are written in the corresponding equation I will discuss later. And photodetector have various applications like in pollution detection, imaging, bioimaging, telecommunication, chemical analysis, thermal imaging and medical imaging. Here is the brief description of device fabrication which is discussed by our pioneer Dr. Nitesh Kumar Chaurasia. We have fabricated all the thin film transistor by solution process, which is a low cost process. And in case of phototransistor, we only deposit a photoactive material PB's quantum dot on the top of the transistor, and another electrode gold is deposited by thermal evaporation method. And in experimental result and discussion, we can see at first the dielectric constant, dielectric characteristics, because we know dielectric is a very crucial element in transistor, and to extract the mobility, we need the capacitance value, that which we can get from the aerial capacitance versus frequency graph. And in case of our lithium alumina gate dielectric, the capacitance is taken at 50 Hz, about 327 nanofarad per centimeter square, and which we have fabricated one thin film transistor with this geometry, and we can see the output clear linear and saturated region of the output characteristics and the transfer characteristics. So why our this gate dielectric is so special? It has a high K value, that is it lower the operating voltage of the transistor. And also we have fabricated one phototransistor where PBS quantum dot is the active material, and when we operate this device, the circuitry is like that. We can change the gate voltage as well as the drain to source voltage, and and we can illuminate the device, and this phenomena is happening here, like the electron hole pair is generated in the previous quantum dot, and it is transferred to the conduction level of the tin oxide semiconductor, and we are getting some photo responsivity. So we have calculated the I light versus I dark, which is I light by I dark versus VG. We get a maximum value of 78. We get the photo responsivity of 6 × 10⁻³ and the reflectivity 2 × 10⁸ joules, and rise time and fall time of 3.27 and 2.48. Actually, it determines that how much speed of the photodetector it is achieving the saturated current level or decreasing the saturated current level. So in conclusion, we can say that we have successfully fabricated ion conducting lithium alumina gate dielectric based thin film transistor on transparent ITO coated glass substrate that will be useful for transparent application field. And also we have achieved excellent transistor properties like mobility of 11 cm² volt inverse second inverse, subthreshold swing of 339 millivolt per decade, which is very lower, on-off ratio of 7.1 × 10⁻² with asymmetric aluminum source drain electrode, and we have manufactured PBS quantum dot phototransistor with asymmetric aluminum source and gold electrode. Actually, this will help to extract charge carrier very fastly. Okay, and the phototransistor devices also exhibit very good properties, and the metal oxide semiconductors significantly improve the transportation of the photogenerated charge, and the gating effect of the transistor increases the photoresponsivity while simultaneously maintaining the I photo or by either picture. Thank you. This is the reference and thank you. Please ask any question if you have.
Thank you, Neela. Thank you so much for your very informative talk. And you have maintained the time constant. I am especially thankful to you. Any more talk? Any more query from audience, please? Neela, are you audible?
Yeah, sir.
Okay, fine. Any more queries from student side, research scholars as well as postgraduate students?
Okay.
Any more query? Okay, thanks, Neela. Thank you so much.
Thank you, sir. Thank you.
Yeah. Thereafter, I would like to call Mahendra Kumar. Mahendra, are you audible? Mahendra, are you audible? Don't be in hurry. I have maintaining the relevance of topic. Actually, many topics are similar. So I am putting here varieties in the quiz of talk. Okay. So please, Mahendra, are you audible to me? Mahendra, are you there? Mahendra, are you there? Mahendra Kumar, Dr. Surendra Prasad. Okay, fine. Shiv Kumar, are you audible? Mr. Shiv Kumar Pal. Mr. Ganesh, there is a problem?
Okay.
Okay, fine. Suradipta Mahathi, are you audible to me?
Yes, sir. Actually, I am audible.
Okay, fine. Please present.
Okay. Is it sharing my screen?
No, your screen.
My screen is shared now?
No.
Actually, it's showing sparing to one. Hello?
Suradipta, yes. Please present your talk. Yes. Please zoom it. Okay, fine.
Good afternoon, everyone. Myself, Suradipta Mahathi, a research scholar, Department of Physics, Jonas Hindu University. Today I am going to present my oral presentation, Hybrid Applied Fiber Bracketings for Sensing Applications. This is outline of the presentation. And first I'll introduce about fiber bracketings. In introduction part, I'll discuss what is theoretical modeling and what are the applications of fiber bracketings and my preliminary work done. Last, I will conclude my research. Fiber bracketings. Fiber bracketings are nothing but optical waveguide coded filter created by periodic modulation of reflective index of waveguide code. At particular wavelength, all the light combined totally and forms a reflection spectrum, and we get reflected. These waveguides will sensor with some specific properties like light wave, output is linear, it can be sensed from very far, and most importantly stability is very long, and size is very much miniature size, and cost of the installation is very low. Because of these tremendous advantages, fiber bracketing sensors have drawn much attention in this days. There are so many fabrication techniques for fiber bracketings, but most commonly three techniques are used: holographic, Regimus, and point-by-point writing technique. But in 1978, first fiber bracketing was demonstrated by Canon, and nowadays it is widely used in various fields of sensing applications. What are the working principles? Already I have discussed the working principles are based on back reflected propagation. At particular wavelength, all the light reflected back at particular wavelength, which got track wavelength printed in equation 1. When light incident on it, some part of light transmitted and some part of light reflected. And this is the reflection spectrum, and it can use as signal. And this is the uniform getting, and this is core, and this is cladding. The role of cladding to confine light inside core by total internal reflection. And this is the reflectment is denoted in equation 2. This is from this equation. You can see that this is sinusoidal variation. So in positive half cycle it is plus, and in negative half cycle it is minus. why I have this apodization, I will discuss later. Reflective equation comes from very basic theory, coupled mode theory, why it is called coupled mode, because forward mode equation is coupled with backward mode, and backward mode equation is coupled with forward mode equation, where the propagation constant and delta beta is a phase mismatch between these two modes. And we have played a little bit trick is nothing but transfer matrix method. Total getting length is divided into finite number of sections, and so each section's length we can correlate with the next layer z to z plus delta by a simple matrix form, which is called transfer matrix. So any arbitrary ith layer matrix denoted here, and by this coefficient 2, 1 and 1, 1 in this matrix, we can directly find reflectivity from this equation 5. This is the mother equation for reflectivity. Here kappa is the coupling coefficient, gamma and delta beta phase mismatch in this way, which depends on total getting length and coupling coefficient and the index modulation. And here mu is the fringe visibility. For calculation simplicity, its value is at x1. And why I have used apodization, I will introduce it. There are so many sides in reflection spectrum due to abrupt change in boundary, because for uniform getting it is constant. But if you use apodization, then there will be no abrupt change in various boundaries. We have eliminated this side lobe. And so many authors have used so many apodization techniques for strain, stress sensitivities and temperature sensitivity. But here I have used two apodizations and combined there in hybrid apodization and found the reflectivity as a form of deep. Here this is the various applications, and keeping this in mind, we have focused on our work in biosensing application, because in recent the biosensing application of fiber blanketing drawn tremendous attention. And our basic layer, here I have shown here, we have optimized our fiber parameters, index of the getting period and co-effective in different drag wavelength here, and we have found reflective increases with increasing getting length. And we have apodized this rest and fine apodization by total getting length and found a deep peak. Instead of sensing this, we have sensed in this deep peak, and if we is the reflective index modulation 1 into 10 to the power minus 4 to 1.5 into 10 to the power minus 4. That means we have increased by 0.4 times 3 times 0.5 value. We have shifted these peaks, and by this we can calculate the sensitivity. Here sensitivity recorded 1.12 micrometer per reflective index unit, and if we further put the length of the getting 10 to 20 millimeter, then we have seen that of the deepness got higher reflectivity side, and this deep sensing can be sensed by changing the sensing signal after changing parameter. We have recorded 0.01 and arbitrary unit per millimeter. To check the side of substitution ability, we have further plotted this logarithmic scale, and we have recorded its right side of substitution ability in first digit, 40 minus 40.45 decibel. In second case, we have further reduced by increasing the index modulation 31.61 decibel. And if you increase the length of the getting 10 to 20 millimeter, then surprisingly, right side lobe is very less, so it can be sensed further. So in sensing application, we have to focus our work in higher length of the getting. Is it commercially available also? So no problem at all. Now I will conclude my work. My analysis shows that reflection of fiber blanketing depends on total getting length and reflective index modulation. In order to high performance of fiber blanketing sensors, sensitivity should be high along with very late side lobes. Although the sensitivity is two pieces. If we increase mod index and if we increase the length, both are nearly equal. But if we increase the length of getting, then side lobes will be replaced. So this is the good for sensitive application. This is my list of publication and conferences I have attended. I would like to acknowledge my supervisor and my RPC members for support and their cooperation in PhD Inspire for providing and pursuing work. Thank you so much.
Okay. Thank you, Suradipta, for a nice talk on such an interesting device, drag rating. Any query from audience side? on drag fiber plating? No. Okay, thank you, Suradatta. Thank you so much.
Okay.
Now I would like to call Utkarsh Pandey.
Yes, sir. Yes, sir.
Okay, please start, Utkarsh.
Okay, sir. Okay, sir.
Thank you, Utkarsh. Please start.
Sir, the screen is visible?
No. It will take time, maybe a few seconds. You do your job, it may take few seconds.
Okay, sir. Okay, sir.
Share your slides.
Okay, sir. Now it is.
Your slide is not. Hello, Utkarsh?
Yes, I am hearing. So, now it is visible, sir?
Yes. It's working.
Okay.
It's working, Utkarsh.
Myself
Yeah.
Myself Utkarsh, and I am here for presenting my research work. And this is the quite similar with the Nitesh sir and the Neelapal ma'am. And this is the synthesis of ion conducting dielectric material, and so solve the technique and the application of the low voltage sensor transistor.
Utkarsh, can you make your voice loud? Utkarsh, can you make your voice loud?
Okay.
You can do something for loudness of voice. Utkarsh, I'm talking about voice.
Okay, sir. Okay. So now I am audible?
Yes, you are audible.
Okay, sir. Okay. So the screen is very well light. So this is the brief introduction about thin film transistor. So thin film transistor is basically a voltage control device having three terminals, source, drain, and the gate. This consists all the components, the metal, insulator, and the semiconductor in the form of layer. That's why it is a thin film transistor. There are few parameters which tells about the performance of the thin film transistor, like threshold voltage, which tells about the operating voltage of the device, mobility, which tells about the speed of the switching speed of the device, and on-off ratio, this tells about the switching property of the device, and same time the sub-threshold thing, it tells about how fast it can move. So this is the schematic diagram of the thin film transistor. Here we can say like this is the substrate and dielectric material, semiconductor. Top of these three, this is the metal electrode. So these two are the output and the transfer characteristics. These all parameters, as I have discussed, is can be calculated from the transfer characteristics. So this is the synthesis process of my dielectric material. Here I have taken the lithium indium titanium oxide precursor in the form of the acetate, chloride, and the chloride. And for all the common solvent I have used, this is the 2-methoxyethanol. When these three precursors are mixed in the 1:1 ratio, then we got the lithium indium titanium oxide material. So this is the material crystallization, means this is the SRD plot, GIF SRD plot of the lithium indium tin oxide, which is this tells about the amorphous nature of the waste, because the analytic temperature of this film is quite low, as earlier reported is the 1150, while I have analyzed up to the 550 degrees centigrade. And also material characterization optical property, because the dielectric material, when we think about the optical property, it should be have relatively higher bandgap. So this is the, and also this is the transmittance, we can say like the bandgap of this material as calculated from this top spot is 5.3 electron volt, and same time this is the, if you have the optical transparency is 87% in the visible band. This is the familiar because we can use the dielectric material. This is the AFM study of the dielectric material, and AFM, because when we talk about the surface morphology, so surface morphology of the device should be very minimum. That's why it gives the quiet performance. And this is the device fabrication step. First we have taken the substrate by cleaning this solution and the acetic acid propanol respectively. I have provided the under plasma cleaning because it makes the film hydrophilic and the pinhole free, which is the makes the adhesion good with the substrate. And in the top of this status, I have put it lithium and tin oxide material, and in second is the semiconductor, and the last one is the electron deposition through the thermoelectric. This is the output and transfer characteristic of the sensor transistor. Here I have taken the tin oxide as a semiconductor material. This is the top of the dielectric material, and aluminium as a electrode. This we have we have the source and neutral for the stable. And this highly doped silicon substrate we have like a gate structure. So these parameters I have calculated from this transfer characteristic. This is the dielectric material, lithium tin oxide, and the area capacitance is 350 nanofarad per centimeter square. The threshold means operating voltage of this is very low. This is 0.1 electron volt. Then the voltage is reduced. At the same time, the on-off ratio is the order of 10 to the power 4. Means it has a very good switching property, and the threshold swing is 330. So let us conclude it. So in conclusion, I can say that I have successfully synthesized this lithium and tin oxide material from Solvay technique, and this shows a good dielectric property in the SiO2 transistor. It is a superior performance, and also we have successfully fabricated low power consuming oxide in transistor, which is the atmospheric resistance very stable, and operating voltage is 1 volt. So it is very less power consuming device, and we have the on-off ratio is 10 to the power 4. So it is assembly. Its switching property is very nice, and this all about the dielectric material lithium, and this loosely bound lithium, and this creates the high K value within the cell. So thank you to all for.
Thank you, Utkarsh, for such a nice presentation, and thank you from my personal side for maintaining time constant. Any queries from audience side? No. Thank you, Utkarsh. Thank you so much.
Okay, thank you, sir.
Deepo Mehto, Alok Ranjan. Sir, I am audible to you. Deepo Mehto, Alok Ranjan from TMBU Bhagalpur. Are you audible to you?
क्या उधर दिया था सबको?
Sir, I am audible to you. Alok Ranjan and Deepo Mehto.
हाँ? हमारा इतना मोटा पैसा है, वो पैसा देना आपको 10 साल तक अभी इसको क्या हमारा पैसा कब मिलेगा ये बताइए। करिए तो पैसा नहीं चाहिए इसको।
अभिषेक रॉय
पेमेंट चाहिए, 1 साल का पेमेंट, 1 साल का सूद ब्याज 1000 हो गया।
अभिषेक रॉय,
अगले साल तो 2 साल।
I am audible to you. अभिषेक रॉय
लेट कर लेंगे और क्या करेंगे?
धीरज पांडे सर,
फ्री का
काइंडली
म्यूट कीजिए ना वहां से, हो जाएगा।
हां ले लेगा 10।
मिस्टर विनय पांडे, कैन यू मिस्टर विनय पांडे
खराब काम करते हैं अपना।
मिस्टर विनय पांडे, can you hear me? Abhishek Roy from Laser and Spectroscopy Laboratory. Am I audible to you? No. M. Jazman from Central University of South Bihar. Am I audible to you? M. Jazman?
Yes, sir.
Okay. Please continue your talk.
Hello.
M. Jazman, I am audible to you?
Yes, sir.
Please give your presentation, please, and maintain time constant.
Okay, sir. Yes, sir.
Okay. Thank you.
Sir, are my slide is showing?
No. Vinay sir, slide. Check the slide, please.
अटेंडेंस हो गया ना? दिक्कत नहीं है?
हेलो।
धीरज सर को म्यूट करिए। हेलो।
हाँ हेलो।
M. Jasman,
yes sir.
Am I audible to you? Please present your talk. Please present your talk.
Yes sir.
Please share your slides.
Yes, sir. Is my slide is here?
No. Mr. Vinay Kumar, sir, please check this issue. Actually, minimize this and please highlight M. Zasman. He's showing his slides. He is sharing. Actually, he's saying he's sharing. Please minimize the our frame. Please minimize.
Is it here, sir?
No, nothing is coming.
Stay for a few seconds. We are checking. Yes.
Yeah. Is it here?
No.
Hello?
There is problem from your side actually. Please repeat.
No,
yours.
sir. Sir, is it here, sir?
Please share your screen, I think.
Please share your screen, M. Zasman.
Please share your
Yeah, I share my screen, sir.
Okay. Can you minimize this frame, Mr. Vinay Kumar?
Minimize, already it is minimized.
Hey, please highlight M. Jasman. He's sharing his slides. Please highlight M. Jasman from Department of Physics, Central University of South Bihar.
हाँ सर हेलो हेलो
Please stay, M. Zasman. Please stay. We are working on it. Yes. The slide is. What is going on?
पिन किया हुआ है सर यहाँ पर नहीं
क्या
उनका तो मेरा हो जाएगा
नहीं क्यों
नहीं उनका ही नहीं तो अपना ही हो जाएगा ये अपना हो जाएगा
हेलो
क्या मुफिद जमीन
यस सर
ये विंडो
हेलो
उससे नहीं होगा या
हेलो
हेलो
यस सर
तो मेन प्रेजेंटेशन आ जाएगा मेन प्रेजेंटर आ जाएगा ना फिर
हेलो
reshare the screen I think then
Can you share your screen, M. Jasman?
Yeah,
You are
I
sharing.
share.
no try to reshare again I think
Try to reshare again, M. Jasman.
Yes sir.
Try to reshare again.
Okay.
We are not getting you actually.
yeah nothing is coming out
वो शेयर यहाँ से सीधा स्क्रीन शेयर हो रहा है अरे उनको शेयर करना होगा यहाँ से वहाँ से शेयर नहीं हो रहा है
problem उनके
M. Jasman, we are not getting you.
now it is coming again
Sir, from my side it is sharing, sir. Share.
Yeah, share now.
He's sharing. He's saying he's sharing.
but nothing is coming out
उसको कॉल कर गणेश
मैं ठीक है
पिन तो ठीक है ये
अच्छा,
पिन
रुक
किया हुआ
जाइए।
ठीक है नहीं प्रेजेंट नहीं
Hello, hello.
M+1, we are working on it.
Sir, from my side it is showing present now, sir.
Actually, we are.
नहीं इधर आ जा रहा एक्चुअली वहाँ नहीं जा रहा एक्चुअली यहाँ जा रहा है
ओके
वहाँ नहीं आ रहा वो चीज़
वहाँ नहीं जा रहा
आ गया
आया 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 लेकिन वो कंटिन्यू नहीं हो पा रहा है
थोड़ा सा डिले होता है
नेटवर्क इशू
ऑफलाइन वाले कर
ओके जसमान प्लीज वेट फॉर सम टाइम फॉर 10 or 20 minutes. There is network issue from your side.
Sir, from my side it is okay, sir.
किससे connect है? Wi-Fi.
Sir, yeah.
Airtel. No, I am not talking to you. I am talking my technical side.
Airtel.
Airtel. Okay. M. Jasman, I am sorry. Please wait.
Okay.
I am calling next. Mahendra Kumar. Mahendra Kumar, am I audible to you? कौन ऑफलाइन पे कौन लेगा बना करके नहीं है
हटाए पहले
स्लाइड मांगी उस पीपीटी Mahendra Kumar, am I audible to you? खुद कहिए देने के लिए ना अपना स्लाइड Mahendra Kumar, am I audible to you? Mahendra Kumar from Photonics Laboratory, am I audible to you? Okay, fine. Dheeraj Kumar Pandey, sir, am I audible to you? Dheeraj Kumar Pandey, sir, am I audible to you? Mr. Dr. Deepak Kumar, sir, am I audible to you?
हेलो हाँ धीरज कुमार पांडे
Am I audible to you, sir?
Yeah.
Dheeraj, sir, am I audible to you?
Yeah, you are audible.
Okay, okay, thank you, sir. Please present yourself, sir.
Okay.
एक्चुअली क्या है ना जब एक स्क्रीन शेयर होती है तो दूसरा को हटाया नहीं करेंगे तो उसकी स्क्रीन हटाई नहीं पहले कर रहा था
Hello.
Dheeraj, sir, present your slide, please.
Okay, just a minute.
क्या है
I will take few seconds.
Keep continue. Present yourself.
प्रेजेंट कर रहे हैं बट वहाँ आ नहीं रहा प्रॉब्लम है हमारे साइड
अरे ये क्या सेटअप किए हुए वही समझ में नहीं आ रहा है
ये वही कर पाएंगे देखिए उसका लिखा हुआ धीरज कुमार पांडे इज प्रेजेंटिंग
Hello.
Hello.
Hello, may I audible?
Yeah, you are audible, but your screen is not coming in our side. Please wait for some, but
Is my screen is shared?
yeah, your screen is shared, but not coming in our big screen. Yeah, there is some problem from our side. ऑफलाइन वाला लेकिन शेयर नहीं हो रहा हाँ एक्चुअली देखो यहाँ आ जा रहा है बट वहाँ नहीं जा रहा है शेयर नहीं हो रहा तो उसको बुलाओ ना कोई नहीं ठीक
I have already shared my screen.
कहाँ गया वो जो है गणेश
उनको कॉल करिए ना
Hello. हेलो
एक मिनट, यही सब बंद करके रखते हैं वीडियो वॉल्यूम और ये भाई बटन इस पे ऑन तो नोटिफिकेशन सेटिंग हो गई।
Wait for few minutes, please.
Dheeraj, please wait
I
for few
did my
minutes. We are working for, to settle the problem.
ओके ओके
लिंक में डिस्टर्बेंस है।
रितेश, यहाँ आ रहा बट वहाँ नहीं जा रहा है।
म्यूट म्यूट अनम्यूट कर।
ये तो खराब है यार।
अरे चल रहा है ना, यहाँ पे चलेगा तो बंद कर देगा, पूरा कर दो।
नहीं प्रॉब्लम नहीं है, ये जो सेटअप किया हुआ है
शेयर कर देना, कोई अभी है नहीं।
कर दो।
यहाँ से तो बोलता रहूँगा यार।
तुम एक काम करो, इसको हमको यहीं पे पकड़ के रखना, इसको
शेयर कर। आई हैव शेयर्ड माई स्क्रीन। और आगे
कितना दूर तक
वीडियो दिख रहा है।
धीरज सर, are you there? क्या प्रॉब्लम है?
स्क्रीन नहीं आ रही।
मैंने सर तुरंत आ जाइए, बहुत दिक्कत हो रही है पिछले आधे घंटे से। ये वो जा क्या चीज जल्दी आइए, वो हो ही नहीं रहा प्रेजेंट, जल्दी आइए।
अभी करिए, धीरज जी का नहीं है, एक दो दिन
Sorry Dheeraj sir for interrupting you. Please wait for a few minutes. We have offline talk from audience side. Who is one? You. Please present. Your name please.
एक बार शेयर करूँ लास्ट टाइम।
जयशंकर प्रसाद।
कोई नहीं है, किसी का साउंड भी नहीं आ रहा।
So we are inviting for oral presentation in offline mode. Mr. Jayasankar Kumar, please come and give your talk.
Hello.
Good afternoon, all of you. My name is Jayasankar Kumar, and my topic is modulation instability in nonlinear magneto-inductive waveguide.
Where is your presentation?
Yes. वो पेन ड्राइव
हेलो हेलो
धीरज सर का हो रहा है।
कॉल आ गया।
मॉड्यूली
ये
भी बड़ा हो जाएगा।
धीरज सर।
Hello, I have shared my screen. May I audible?
Yes, you are audible, Dheeraj sir, but your slide is not showing here.
Yes sir, now you are audio. Yes sir.
Now my slide is coming.
Yes sir.
May I start? Hello, may I start my presentation?
Yeah. Dheeraj sir, continue.
Okay. My screen is available there. Hello.
Hello.
Is my screen is available there?
Yes sir.
So I am starting. Hello.
We are working to settle this problem. Dheeraj sir, start now.
May I start? Yes or no?
Yes, you can start.
Start.
Okay, okay. Thank you very much to the organizing committee to invite me to present my talk in this event. The title of my presentation is a density functional based study for physical properties of the most stable zinc telluride nanoclusters. Myself is Dheeraj Kumar Pandey from Physics Department of RV College, Dalsingsarai. This is the content of my presentations, and my presentation is divided into 4 sections. Introduction, theoretical techniques, that is about the density functional theory. Third one is about the zinc telluride nanoclusters and their calculation and results, and after all the conclusion. First of all, I want to introduce with the nanoclusters. Usually in nanoscience and nanotechnology, nanoclusters is a zero-dimensional structure, but we have defined it as a non-periodic 3-dimensional structure, and it is an intermediate state of matter between molecule and bulk. What is the interesting thing about the nanoclusters which make it to be interesting? One thing is that when the number of atoms change in the nanoclusters, their physical properties also change in non-smooth way. I have chosen ab initio method for study the physical properties of the nanoclusters. And ab initio methods is that methods in which we do not imply any experimental data. We just require only the ions present in that particular atoms of the nanocluster. Nanoclusters can be considered as many electron system, and then for such systems, Schrödinger equation is given by this, where V effective represents the effective potentials. If we can measure accurately the effective potential experienced by an electrons, then we can easily determine the physical properties of the nanocluster. In order to determine the energy of many body system, we have implied the density functional theory. The ground state energy in density functionals is given by the equations E, which is representing the ground state energy, which is the function of density, and it is the sum of the 3 types of energy, in which first term represents the kinetic energy, second term represents the interaction energy with the external potentials, and third term represents the electron-electron interaction energy. This electron-electron interaction energy is further sum of the 2 types of energy, one of the interaction with the neighboring electrons, and last one term represents the electron exchange correlation energy. This exchange correlation is very difficult to determine accurately. It has several approximations. First approximation about the exchange correlation energy is local density approximations, in which the energy is considered as a function of only density. But this approximations does not give better result for the nanoclusters which has higher atomic numbers. So a new approximation was introduced, that was the generalized gradient approximations. In generalized gradient approximations, ground state energy was considered of density as well as its gradient, but this approximation has also certain limitation. So a new approximation was introduced by Becquet, Lee, Young and Parr. That's why it is known as B3LYP, and it is also known as hybrid functionals. This gives the better result in comparison to LDA and GGA. System. I have chosen the system of zinc telluride materials. Usually a bulk zinc telluride is a wide bandgap semiconductors having direct bandgap of 2.26 electron volt. This zinc telluride materials in bulk phase has several potential applications like fabrication of polymorphic devices, semiconductor electronic panels, detectors of X and gamma rays. So, in our theoretical calculations, first we have tried to obtain the most stable structures of zinc telluride up to 5 atoms. Then we have tried to find out their electronic properties and then vibrational properties. In this way, up to 5 atoms, we have obtained different types of 44 stable structures of zinc tellurides. In this way, we have taken different types of linear chains, rings, planars, and three-dimensional structures for each nanocluster size, means for 2, 3, 4, and 5 atoms. In the convergence, the system energy is converges up to 10 to the power minus 7 milli-electron volts, and the forces on each atom in each nanocluster was obtained up to less than 10 to the power minus 3 electron volt per angstroms. Then we have calculated the binding energy. This binding energy is obtained by subtracting the total energy of a nanocluster with the sum of the energy of all the isolated atoms present in that particular nanocluster. This resultant quantity was divided by the total number of atoms present in that nanoclusters. Then we obtain the binding energy per atoms. We have also calculated the 0 point energy, which was ignored by the other workers, and this 0 point energy was subtracted to the binding energy to obtain the final binding energy. On the basis of final binding energy, we have decided the most stable structures, but that particular structure must have real vibrational frequency. These are the total most stable structures for 2, 3, 4, and 5 atoms. In this figure, we have just taken only the most stable structures. At last, we have tried to find out the variation of the final binding energy, and we see that from the curve, maximum number of telluride atoms.
Yes, sir. So good afternoon. My conference presentation is on properties of electromagnetic Bloch surface waves at the interface of two photonic crystals in mid-higher frequency region. So I will begin with a brief introduction into photonic crystal, its classification, and types of Bloch surface waves, theoretical methods. So what are photonic? Photonic crystals are naturally occurring or artificially designed periodic stratified structures whose periodicity is comparable to the order of incident wave. So when light is incident on the periodic structure, then if the reflected waves are in phase, then due to constructive interference, it forms a photonic band gap. And when they are out of phase, then destructive interference leads to formation of allowed band gaps. So photonic crystals are classified as 1D, 2D, and 3 dimensions. So we can localize the electromagnetic energy in any of these dimensions. So what are Bloch surface waves? Bloch surface waves are electromagnetic surface waves that occur on either side of the interface. So here it is represented sounding medium and the photonic crystal. So there are 4 types of Bloch surface waves: EE, EG, DE, and DD states. So only the DD type of surface states that decay on both sides are localized at the interface, while rest are non-localized. So in order to find the expression of Bloch surface waves inside this periodic stratified media, we start with the propagation of EM polarized wave with these field vectors satisfying the Maxwell's equation. So inside this periodic structure, the Maxwell equation gets reduced to this Field's differential equation, whose solution is superposition of two Bloch waves, which we obtain by using transform matrix method. So by applying the transform matrix method, we obtain the unit cell translation matrix ABCD, through which we get the dispersion relation. Further applying the Bloch-Blockade theorem, we get the equation of wave inside this periodic stratified medium, which is referred to as the Bloch wave solution. So my present work is the localization of energy at the interface of two photonic crystals. So here we have considered two photonic crystals. One is less than Z0, another is greater than Z0. So by solving the transform matrix, we obtain these AB elements, through which we get the mode confinement condition as follows. So the electromagnetic band diagram for the TE dispersion is as follows. If we zoom this portion, we obtain that 3 modes are localized in the photonic band gaps. The red dots and the blue dots correspond to beta 3, and beta 1.2 corresponds to the red dot. So modes are localized beta less N1 and N2. So the confined modes are following values. 7 photonic band gap is confined with cost lambda less than -1. And for photonic band gap 6, it is confined for greater than 1. Now the field profile of the corresponding gross surface wave is depicted here. So it shows the typical decaying nature of gross surface waves on either side of this interface plane with a decay length of around 49 microns. Here we see that at the peak, the gross surface wave is at the interface, which is referred to as an even interface. So the intensity profile of the multi-flare structure shows that the field is most intense at around equal to 0 interface, and then it actually tends to 0 for higher number of flare cells. So this is my conclusion. So light can be localized using design parameter V1 and V2. The decay length of the edge modes are much larger, which at the edge are loosely bound. So the application which we can see through our proposed structure is biosensor, temperature sensing, optical filter, band and laser, and optical control. Thank you, sir.
Okay. Thank you, thank you, Mahen.
Hello?
Yes.
Thank you so much, Mahen, for such a nice topic on in photonics. Now I will call Deepo Mehto.
Yes.
Am I audible to you?
Yes, I am ready.
Yeah, kindly present yourself. Deepo Mehto, sir, for your invited talk. Dear artists, kindly spread the feedback form and also collect them. Deepo Mehto, sir. On the topic change in mass spinning black holes relative to the angular momentum. Deepo Mehto, sir, am I audible to you?
Hello?
Deepo Mehto, sir, am I audible to you?
Yes, yes.
Kindly present yourself.
Yes, I am preparing my desktop.
You are Alok Ranjan, Pankaj Roshan.
Alok Ranjan.
And the name is showing Pankaj Roshan on the screen. Whom I am talking?
Hello?
Whom I am talking? Your name, please.
Hello?
Actually, your name is showing Pankaj Roshan. Okay, fine. Please, sir, continue.
Hello?
Please, sir, continue yourself.
Yes, वही निकल रहे हैं, उसी पे कंटिन्यू कर देते हैं, इसी पे निकालेंगे सर। हाँ, जरा स्लो चल रहा है। हाँ, कर रहे हैं, स्लो चल रहा है, वही डायरेक्ट डेस्कटॉप निकलेंगे पढ़ रहे। हाँ, हेलो? हेलो?
Mr. Deepo Mehto, sir, present yourself. We have a time limit.
The title of the paper is Change in Mass as Black Hole Relative to the Angular Momentum. And the present research work proposes a model for the change in mass of uncharged spinning black holes with respect to angular momentum using a well-known relation.
Mr. Deepo Mehto, sir, we are not able to see your slides. It's looking blank.
Sir, wait.
Actually, we can't wait, sir. We have called you so many times during the session. We have lot of speakers who are in queue. Mr. Shiv Kumar.
Poor, sir, so
Mr. Shiv Kumar, sorry sir, sorry to interrupt you. Please wait for some time. We have lot of speakers in a queue. Mr. Shiv Kumar Pal, am I audible to you? Mr. Shiv Kumar Pal, am I audible to you? Mr. Shiv Kumar Pal, am I audible to you? Deepo Mehto sir, please wait for some time. We have a time constraint. Mr. Shiv Kumar, I'm audible to you. Shiv Kumar, your headphone is not working. Can you change your headphone? Mr. Shiv Kumar, directly present yourself through PPT.
The PPT is not shared. Not shared, sir.
Not shared.
Yes,
Why?
Share. At share. Why I click share? It is not working.
Okay. You can wait for some time.
Okay, sir.
Okay. Mr. Abhishek Roy. Mr. Abhishek Roy. Mr. Abhishek Roy. Deepak Kumar. Mrityunjay Kumar Mishra. Anyone are there? Okay, someone is here. Call me. Savita, Miss Savita. Yes. Mrityunjay Kumar Mishra. Are you there?
Yes, sir. Yes, sir.
Can you present yourself?
Hello, sir. Madhu Kumari Gupta. Can I present my research?
Ma'am, of course.
Hello.
Ma'am,
Yes,
of
sir.
course.
I am ready,
but
sir.
Please wait, ma'am. Madhu Gupta, ma'am, please wait. After Mrityunjay, you will present.
Okay, sir.
Mrityunjay Kumar Mishra, please present yourself.
Yes, sir. Hello.
Mrityunjay Mishra, do fast. Please present yourself. We have several talks.
Yes, sir. 1 minute. Yes, sir. Slide is visual, sir.
Can you share your slides?
Yes, sir. Hello.
Mr. Mrityunjay, we are waiting for your talk. Can you share your slides? Do you have some PPT presentation? Do you have PowerPoint presentation? Please share.
Yes, sir.
Please share yourself, your slides. Mrityunjay Mishra,
Yes, sir.
can you present yourself?
Yes, sir.
Please do.
Slides on or not?
Mrityunjay, I am sorry to interrupt you. Miss Madhu Gupta. No, we are not seeing your slides.
I have already said.
No. Our technical team is saying there's no slide on the screen.
Sir, can I present, sir? Madhu Gupta, sir.
Okay, ma'am. Please wait. Mr. Mrityunjay, can you wait for some time? Madhu is here. Miss Madhu Gupta, can you continue?
Yes, sir. I am sharing my slides, sir.
Okay, share yourself. Mr. Madhu, Miss Madhu,
Ji, sir.
continue yourself.
Ji, sir. I am just presenting my slide. Is it visible, sir?
Yes.
Okay, sir. I am starting my presentation, sir. In this presentation, I am presenting the antifungal activity of copper-piperazine dibiguanide hydroxide against 2 aspergillus fungi. First is the introduction. What is this bigonide? Bigonide is also used as a compound in order to control hyperglycemia. Bigonide is a bidentate chelating molecule and its complexes with bivalent as well as trivalent ions. This is known to everyone. You can see the picture, or one can say the structure of bigonide, in which nitrogen 2 and nitrogen 4, both these can undergo chelation, formation of chelation ring by coordination bond formation with many transition metals. Chemically and structurally, these bigonides are similar to guanyl urea and biuret. How they are connected? In bigonide, two guanidine molecules are joined together with the elimination of ammonia to give bigonide. Similarly, one urea molecule and one guanide molecule will combine and gives guanyl urea. Similarly, two urea molecules makes biuret. When you see these molecules, in this case, biuret, if one double bond oxygen is replaced by double bond NH, it will form guanyl urea. When both the oxygen get replaced by NH, then we will get bigonide. This I have written in language. Bigonide 1 and guanyl 2 may be reviewed as derived from the substitution of one or both the oxygen atom of third by corresponding number of imino groups. At the same time, biuret 3 is a condensation product of two molecules of urea, guanyl urea, diamide. It may be represented as derived from the condensation of one molecule of urea and one molecule of guanidine. The same thing that I have already presented you. Now we will move towards another slide in which we have represented the ligand. Piperazine dibigonide sulfate. It is a coordinated chelating ligand in which different nitrogen atoms, that is in the imine group, it undergoes chelation to give you the product. Now we will move towards second slide, the main work which was done, experimental work. First we have prepared the piperazine dibigonide ligand and then complex with copper metal ion. Further we have prepared PDA potato dextrose agar and sabor dextrose agar mediums. Further we have checked whether the complex has been formed or not by elemental analysis, UV spectra and IR spectra. Further we have tested the antifungal activity by dilution test method, which I am representing. When we have done the dilution test method, we have seen that copper piperazine dibigonide hydroxide in PDA medium and SDA medium for aspergillus niger at 400 microgram per ml concentration. In PDA medium, 96.97% control was there. In SDA medium, it was 94.30%. Similarly, when we talk about versicolor, under the same 400 microgram per ml concentration, it was 100% efficient to control the growth of fungus in PDA medium and 99.10% in SDA medium. So one can say Aspergillus versicolor is more prone to get killed by copper piperazine dibigonide hydroxide. Both these tests was done with the help of DMSO solvent. We have prepared the solvent. We have prepared the solution in DMSO solvent to have the result which I have written in last. The complex are more efficient to control the growth of Aspergillus versicolor in both the medium. Thank you.
Thank you, Dr. Madhu.
Sir, any question?
Yeah, any question from audience?
Hello.
Side? Any question from audience side? No question, ma'am. Thank you, Dr. Madhu, ma'am, for such a
thank
nice
you, sir.
talk.
Thank you, sir.
Yeah, on antifungal activity.
Thank you, sir.
Okay. Thank you, ma'am.
Thank you, sir.
I will call Mrityunjay Mishra. Are you there? Am I audible to you, Mrityunjay Mishra?
Yes, sir.
Can you share your slide? Can you share your slide, please? Mr. Mrityunjay Mishra, can you share your slide, please? Mr.
Yes, sir.
Shiv Kumar Pal.
Yes, sir.
Yes, sir.
Shiv Kumar Pal, can you share your slide?
This is Shiv.
Is it possible
Hello.
for you?
Yes, sir, I am trying.
Okay.
It is not shared due to some network issue, maybe.
Okay, fine. Mrityunjay, can you
Yes,
share
sir.
your slide? Miss Savita, are you there? Miss Savita, are you there? Can you hear me?
Yes, sir. Yes, sir.
Can you present yourself?
Yes, sir.
Please present yourself. A review on nanomaterials.
Okay, sir. Thank you, sir. Good evening, all of you. Today I want to represent on a presentation of the nanomaterials.
Miss Savita, do you have PPT presentation?
Yes, sir. PPT presentation, OP number 24.
Okay, fine. Can you share your slides, please?
Yes, sir.
Miss Savita is from Haryana. Ma'am,
yes,
can you share your slide?
Yes, sir. Yes, sir. But just wait a minute, sir.
Okay, fine.
Yes, sir. My topic is review on nanomaterials.
Ma'am, can
firstly,
you make it landscape? Can you turn your mobile horizontal?
yes, sir. Yes, just wait a minute.
Must do.
इसको एक स्लाइड पे ये तो ऐसे
मोबाइल को ऊपर से रोटेशन ऑन करना है।
मैम उसको लैंडस्केप में कीजिए कि रोटेशन आपका ऑफ है, उसको रोटेट कर लीजिए।
ये
वो सेटिंग में जाइए। हाँ
ये
या yes it is visible. Present your talk, please.
Yes, thank you, sir. Okay, sir. My presentation on the nanomaterials. So first of all, I am Savita, Department of Physics, Indira Gandhi University, Mirpur, Rewari, sir. Okay. First, we consider term related to the nanoscience. So firstly, we know about what is the nanomaterial. Sir, I am audible?
Yes, you are audible, but yes, you are audible. But maintain your time constant, please.
Okay, sir. Thank you, sir. So, first of all, we explain the term related to the nanoscience. Nanomaterials are those materials which have dimension at least in 1 to 100 nanometer range. So what do we mean by the nanometer range? It is meaning that 1 billion part of something. Nanoscience is related to the nanomaterials, the study of the fundamental principle of molecules and structure with at least one dimension, roughly 1 to 100 nanometers. And what is the nanotechnology? Nanotechnology is by the application of the nanoscience, we can make the devices. We can functioning the material using the nanoscience are called the nanotechnology. Okay, again, historical backgrounds. The firstly nanotechnology word are explained by the Richard Feynman in 1959 in the conference. The principle of physics, as far as I can see, do not speak against the possibility of the measuring thing atom by atom, and we can say that he says that there is a plenty of proof at bottom. He says that we can assemble the atom by atom. The word nanotechnology was first used by Nario Technology in 1974 to refer the precise and accurate tolerance required for machining and finishing the materials. The term nano derives from the Greek word dra. The nanometer is billionth part of meter. I want to explain the second. What is the nanomaterials? I already explained that the material having at least one dimension in the nanomaterial scale. Nanometric scale are called nanomaterial. Nanotechnology is understanding and control the matter at a dimension roughly 100 nanometers, where unique phenomena enable novel applications. Encompassing nanoscale science, engineering and technology. Nanotechnology involving imaging, measuring, modeling and manipulating the matter at a atomic level, molecular level. The term an umbrella term that covers the discipline and every old historic. What is the so special about the nanotechnology facilities incredibly broad, interdisciplinarily fit. It requires expertise in physics, chemistry, material science, biology, mechanical, electrical engineering, medicine, and other collective knowledge. The boundary between atom and molecule and the macro. What is special nanomaterial? At the nanoscale, the physical, chemical, and biological properties of material differ in fundamental and valuable ways. The properties of individual atom and molecule and the bulk matter. We can say that the nanomaterials are different from the bulk material, which have the many properties which are different from the bulk material. Because of the small size, nanoscale size, we know that if we reducing the size, then some of the properties of materials are changing. With reduction in size, the surface area of material and surface energy increases tremendously. We can say that if we decrease the size of material, surface area increases, surface to volume increases. So that so many properties of material are changes. Like as the reactivity, chemical stability. So on the basis of these quantum confinement and surface to volume ratio, we can change the application of material and we can functioning the materials. On the basic classification of materials, there are type of materials, one-dimensional materials, two-dimensional materials, three-dimensional material. From the one-dimensional material, we can say that out of three dimensions, in the one dimension of the material in the nano range. And the two-dimensional materials, we can say that the two dimensions of the material in the nano range, and three-dimensional materials, we can say that three dimensions are in the nano range. Nano range means we say that 10 to the power minus 9 meter. The example of the nanomaterials in the 0 dimension, full range, 1 dimension, carbon nanotube, and graphenes and graphites. So these are the carbon nanomaterials, carbon-based nanomaterials. Synthesis of the nanomaterial, we can synthesize the nanomaterial by the two basic methods, top-down approach and bottom approach methods. Top-down approach, we have the name is clearly seen that top-down means from the bigger size we arrive at the smaller size. Top-down approach involves the breaking down of the bulk material into the nano-sized structure or a particles. Top-down synthesis technique are extension of those that have been used for producing the micron-sized particles. Few methods for a top-down process are explained: ball milling method, plasma arcing, laser scattering, vapor deposition. Ball milling is a very basic example for the top-down method. In this case, we get a powder form of a
material.
material.
Very fundamental topic for all research scholar and post-graduate students. Please hear. She is delivering very nicely. Yes, ma'am. Continue.
Okay, thank you. Okay, top-up approach or self-assembly. In this case, we can say that the atom by atom, we achieve a nanoparticle size. Nano fabrication use the chemical or physical forces operating at the nanoscale to assemble the basic unit into the large structures. Researchers hope to replicate nature's ability to produce small clusters of the specific form, which can be then self-assembled into the more elaborate structure. Because of these properties self-assemble, we can use the nanoparticles in medicines also, and so many applications are there. A few method bottom approaches are sol gel, colloidal, electrode deposition, and now I am firstly explain here. And these are the top-down approach and bottom approach. Top-down में हमें पता है transformation by energy in a small particle and we get a powder form which is in the nanoparticle range. Example of the full range and diamonds, graphene are the example of the nanostructure particle on the top-down approaches. And bottom approach, the ionization by energy and condensation of the formation of the cluster, and these are the nanoparticle structures. Here and also explain top-down and bottom and bulk material to powder. This is top down and bottom as atom assemble into the cluster form and we get the nanomaterials. Significance of the nanoscale, it is observed that properties are distinct from the nanoscale from the large scale. I also explained there the bulk material from the nanoparticle size because of the two effects. quantum size effect and surface to volume is increased. So that because of these properties, all the properties are increased. All the properties of the material are changing. As physical properties, mechanical, magnetic, optical, thermal, and surface area, catalytic activity, electrical properties, and semiconductors. These properties are changes due to their surface to volume ratio and quantum confined effect. Nanomaterials in nature, these are the few examples which are explained that the nanomaterials are already exist in the nature. Butterflies, wings, and the peacock. Due to their structure, they have remarkable property because of the inherent nanostructure. These are given by the nature. Okay, and applications, we know that because of the high surface to volume rate, quantum confinement, because of these properties, many applications are there in the paints, incorporating nanoparticle in paint and could improve their performance. It can impart various functions like properties, self-cleaning. These are applications in medicine. We also know that we use the nanoparticle which are effect on the targeted cell, and these are not influence the other cells, so that in the medicine nanoparticle have the very much useful. And the sensor for sensors में भी हम इनको use करते हैं. Energy harvesting में भी हम nanoparticles को use करते हैं. And for इसमें मैंने और इसमें डाला नहीं है. I think pollution को control करने के लिए भी हम nanoparticles का use करते हैं. We know that the solar particle या disensitized solar में we use the nanoparticles. Because of nanoparticles, we use a platinum catalytic activity, because surface to volume increases, reactivity is also increases, and using the catalysis which are increase the activation energy. Okay, so that we have the many applications in the nanomaterials. Okay, and application tougher and harder cutting tools. We know that the carbon nanotube materials are very hard, which have the high mechanical strength and high reactivity, so that these are used in cutting tools. ठीक है, हार्डर कटिंग टूल्स में हम इनको यूज कर सकते हैं, हाई पावर मैग्नेट्स में यूज कर सकते हैं, टू स्टोरेज द मेमोरी डिवाइसेस वी कैन आल्सो द नैनोमैटेरियल्स. ओके, थैंक यू सर.
Thank you, Savita, for such a nice fundamental talk. Now,
thank you so much.
Thank you, Savita. Now I will call M. Jazman. Are you there? M. Jazman.
Hello, sir.
M. Jazman.
Hello. Hello. Hello, sir.
M. Jazman.
Can I present?
Who is?
Hello.
Who is?
Hello. Ritesh sir. I am ready, sir.
Shivkumar Pal. Shivkumar Pal.
Yes, sir.
Who is ready? Who is ready for talk? One by one, please. Who is ready for talk? Mrityunjay Mishra.
Hello, sir. Can I present?
Who is Menka Yadav?
Yes, sir. I am here.
You are. Savita is presenting on your own behalf, right? From Department of Physics, Indira Gandhi University, means you. Yeah, Menka Yadav.
Am I audible, sir?
Menka Yadav, please wait for some time. Please wait.
Hello.
Menka Yadav, please wait. Your oral presentation is 40.
Yes, sir.
Number is 40. Please.
A very good evening to all of you. Today I want to present preparation and properties of cutting tool methods and cutting tools. Cutting tools plays very.
Miss Menka, your slide is not showing.
म्यूट कर दिया मैं उस मेनका को.
म्यूट कर दिया. नहीं, करने दीजिए. Miss Menka, your slide is not showing to us. Miss Menka Yadav.
अनम्यूट करना पड़ेगा. बोल दिया.
Hello, sir.
Miss Menka Yadav.
Sir, please unmute.
We are not able to hear you. Mrityunjay, are you?
Sir, am I audible now, sir?
Yeah, you are audible. Can you present your slide, Miss Menka? One by one.
Yes, sir.
Yes, sir. Miss Savita, please mute yourself. Yes.
Yes. Thank you.
Menka, please
A very
continue.
good evening to all of you, sir. Thank you for giving me such a great opportunity. Today I want to present preparation and properties of cutting tool methods. Cutting tool methods play very important role in the cutting edge preparation methods, and the objectives of our presentation are: use the nomenclature of a cutting tool point, explain the purpose of each type of break and clearance angle, identify the applications of various types of cutting tool materials, describe the cutting action of different type of machines. Firstly, we will discuss about the cutting tools. It is one of the most
Menka, do you
important
have PPT? Do you have PPT? Can you show your PPT?
Yes, sir, I will minimize it.
No.
I will not take too much time.
Can you show your PPT? We are not able to see your PPT, PowerPoint presentation. We are not able
Just a
to see
minute.
your slides actually. Are you?
Okay, sir. I am sharing again, sir. I am sharing.
Okay. First, share your slide. Now it is okay. Okay.
It is okay now, sir?
No. Please do in landscape mode. Rotate your. Yeah.
Now it is okay, sir.
Yeah. This is okay. Please continue, Dr. Menka.
Okay, sir.
Yes.
Use the nomenclature of a cutting tool point, explain the purpose of each type of break and clearance angle, identify the applications of various type of cutting tool materials, describe the cutting action of different types of machines. Cutting tools plays very important role in cutting edge materials, one of the most important component in machining process. Its performance will determine efficiency of a operation. There are two basic types excluding abrasives: single point and multi-point cutting tools. It must have rake and clearance angle ground or formed on them. Cutting tool materials. Lathe tool bits generally made of 5 materials. It requires high-speed steel, cast alloys, cemented carbide, ceramics, and cermets. More exotic finding bidules, boragon, and polycrystalline diamonds are also used. In the lathe tool bit properties, its properties mainly consist of: it is very hard and wear resistance. It is capable of maintaining a red hardness during machining operation. We can describe red hardness as it is an ability of cutting tool to maintain sharp cutting edge even when turns red because of high heat during cutting. Because high heat is produced in this process, it is able to withstand shock during the cutting, shaped so as can penetrate work. High-speed steel tool bits. It may contain combinations of tungsten because it can bear very high temperature, chromium, vanadium, molybdenum, cobalt. It can take heavy cuts, withstand shock, and maintain sharp cutting edge under red heat. Sometimes in the operation, many times we require these sharp cutting edges. It generally consists of 2 types: molybdenum based. It can be described as group M, and tungsten base, we refer it as group T. Cobalt is also added if more hardness desired. It depends upon the hardness up to which amount we need it. Cemented carbide tool bit. It is capable of cutting speed 3 to 4 times high speed steel tool bits. Low toughness but high hardness. Hardness is high and excellent red hardness. It consists of tungsten carbide sintered in cobalt matrix, straight tungsten used to machine cast iron and non-ferrous materials. Different grades for different work. Coated carbide tool bits. It is made by depositing thin layer of wear resistance titanium nitride, titanium carbide, or aluminum oxide on cutting edge of tool. Fuse layer increases lubricity, improves cutting edge wear resistance by 200 to 500%, lower breakage resistance up to 20%, provides longer life and increased cutting speeds. Titanium coated offer wear resistance at low speed, ceramic coated for higher speeds. Ceramic tool beds, it permits higher cutting speeds, increased tool life and better surface finish than carbide. It is weaker than carbide used in shock-free or low shock situation. In ceramics, heat resistance material produced without metallic bonding agents such as cobalt, aluminum oxide, most popular additive we can add it, titanium oxide or titanium carbide, it can also be added. In diamond tool bits, it is used mainly to machine non-ferrous metal and abrasive non-metallics, single crystal natural diamonds, high wear but low shock resistance factors, polycrystalline diamonds, tiny manufactured diamonds fused together and bonded to suitable carbide substrates. These are cutting tool nomenclatures: point, face, nose, radius, cutting edges. These are the main parameters of cutting tools. Cutting edge, it is a leading edge of that does cutting. Face, surface against which chip bears as it is separated from the works, and it is the most important part of cutting edge material. Nose, tip of cutting tool formed by junction of cutting edge and front face. Cutting tool nomenclature again: nose radius, radius to which nose is ground. Size of radius will affect finish, rough turning and finish cuts. Points, end of tool that has been ground for cutting purpose. Flank, base and shank. Base, bottom surface of the tool is known as base. Flank, surface of tool adjacent to and below cutting edge is known as flank. Body of tool bit or part held in tool holder known as shank. Lathe tool bit, angles and clearance is shown in this figure. Lathe cutting tool angles, negative rakes, face of cutting tool contact metal, first and chip moves up the surface of the tool bit. Positive rake angle, it is considered best for efficient removal of metal. It creates large shear angle at shear zone. It reduces friction and heat. It allows chip to flow freely along chip tool interface. Generally, it is used for continuous cuts on ductile materials, not too hard or abrasive. Factors when choosing type and rake angle for cutting tool: hardness of metal to be cut, means which metal we want to cut, type of cutting operation, material and shape of cutting tool, and strength of the cutting edge. Shape of chip. Altered in number of ways to improve cutting action and reduce amount of power required. Continuous straight ribbon chip can be changed to continuous curved ribbon. Changing angle of the needles included angle produced by grinding side rake, grinding chip breaker behind cutting edge of tool bit. Tool life. Crater wear occurs as a result of chips sliding along chip tool interface, results of built up edge on cutting tool, and it is this diagram shows the tool life. Factors affecting the tool life of a cutting tool: type of material being cut, microstructure, hardness, type of surface, material of cutting tool by which it is made up, profile, type of machining operation being performed, speed, feed and depth of the cut. Turning. Assume cutting machine skill. If rake and relief clearance angles correct and proper speed and feed used, a continuous chip should be formed. Like turning is shown in this figure. Nomenclature of an end mill is shown in this figure. Here we have primary clearance angle, radial rake angle, secondary clearance angle, tooth face, cutting edge, flute and land. Nomenclature of an end mill can be shown like this way. Characteristics of a drill point is this: cutting point angles for standard drill: for angle 90 degree, 118 degree and 150 degrees shown in figure. And in this way we can describe the cutting tools which plays important role in the preparation, cutting edge preparation methods. We have so many cutting edge preparation methods: thermal and mechanical methods, laser, abrasive material coatings and honing of the surface. So many methods are available in which tools plays important role, and this plays very important role in the designing of a chip and a material for a particular operation. Thank you, sir.
Is it over, Menka?
No, sir. No, sir. No. It's okay, sir.
Do fast, please. We have time constraint. We are moving towards valedictory.
I have ended my presentation, sir.
Can you conclude your talk, please? Can you conclude your talk, Menka?
Yes, sir.
Can you conclude your talk, please? We have our dignitaries on the dais. I am stopping here. We have our dignitaries on the dais. I will call.
Sir, you are not audible, sir. I cannot answer, please.
Menka, can you conclude
Yes, sir.
yourself, please? Can you conclude yourself, please? We have a time constraint.
Okay, sir.
And
Sir, we have several
dignitaries on the
mechanical
dais.
and thermal cutting edge methods are available in which tool bit plays important roles. We have several methods like link.
Dear Menka, your slide is not moving. We are not able to. Yes. Conclude yourself. Please go on conclusion.
Yes, sir. Sir, conclusion is this. Tool bits plays very important role in cutting edge materials.
Okay.
Whether this, whichever type of method we use, tool bit plays important role, sir.
Okay, fine. Have you finished? Have you finished, Menka?
Yes, sir. I have finished, sir.
Okay. Thank you, Menka.
Okay, sir.
We
Thank
have
you,
our
sir.
dignitaries on the dais. Our Honorable Pro Vice Chancellor Ma'am. We all welcome to our Pro Vice Chancellor Ma'am, Professor Dolly Sinha. I will call the President of this particular national seminar, Professor Arun Kumar Singh. Sir, please welcome, ma'am.
मंत्रासीन प्रोफेसर मैम, इस विभाग के फॉर्मर अध्यक्ष प्रोफेसर अरुण कुमार सर निर्भय नारायण चौधरी जी, वो मेडिकल लीव में थे, फॉर्चुनेटली उन्होंने आज ही ज्वाइन किया। तो इन सबों के लिए मेरा एक ही शब्द है कि आप सबों का इस घर अपने घर में स्वागत फिर से, क्योंकि मैम के बारे में हमने इनॉग्रल सत्र में कहा था कि ये फिजिक्स की इमिनेंट स्कॉलर हैं, अरुण मिश्रा सर भी इमिनेंट स्कॉलर हैं और सर तो विभागाध्यक्ष ही हैं, इसलिए पुनः सबों का अपने ही घर में मेरे द्वारा स्वागत। और समापन सत्र की ओर इसलिए हम लोग बढ़ रहे हैं, मुझे पता है कि अभी बहुत सारे ओरल पेपर्स बाकी हैं, लेकिन अरुण मिश्रा सर को क्योंकि पटना से आए हैं, उनको पुनः लौट के पटना जाना है और मैम का भी वीसी सर के अनुपस्थिति में बहुत ही व्यस्ततम शेड्यूल है, इसलिए इस सत्र को बीच में ही रखना पड़ा। तो आप लोगों से आग्रह, इस सत्र में अपनी सहभागिता रखें और मैम के द्वारा आशीर्वचन, सब लोगों के द्वारा आशीर्वचन को ग्रहण करें और पार्टिसिपेंट्स के द्वारा जो आपने, हम उम्मीद करते हैं कि 12:45 से हमारा ये तकनीकी सत्र शुरू हुआ है और 4:15 बजने जा रहा है। तो ये 4 घंटों का जो मैराथन तकनीकी सत्र था, उसमें आप लोगों ने क्या क्या समझा, क्या क्या सीखा, उसके बारे में आप लोगों में से भी अपना फीडबैक आकर के यहाँ देंगे और आगे का जो प्रोसीजर है समापन सत्र का, उसके लिए मैं इस सेमिनार के कन्वेनर डॉक्टर आर के चौरसिया जी को मैं सुपुर्द करता हूँ। आगे का कार्यभार डॉक्टर रितेश कुमार चौरसिया से संभाल।
Thank you, Professor Arun Kumar Singh sir, for the given me opportunity. Now it's a valedictive program and it's particularly the feedback from the student side. So I will call one by one students to give the feedback about the this national seminar NSCEMS. Please come one by one and give your feedback. Anyone from student side? Already you have given in hard form. but I wish, please come on the dais. What you have learned, please share yourself. Please come. Rushda, Avinash, Shalpriya. हम लोग तो हमेशा बोलते रहते हैं, ठीक है? प्लीज कम, आगे आ जाइए, सभी लोग आगे आ जाइए। क्या आपने सेमिनार से सीखा, क्या रह गया, ठीक है, और क्या आप लेकर के जा रहे हैं? इसी टाइम फ्रेम में आप लोग रहिएगा, क्या लेकर के जा रहे हैं, क्या सीखा और क्या रह गया, ठीक है?
Good afternoon all of you. My name is Shalibra from PG first semester, and this is my first seminar, and this is a marvelous for me. I learned more about things related to physics. Most of the main point of view is TFT because I have no knowledge of TFT. I don't know. I am not hearing about this, and I know only MOSFET, FET, and transistor, etc. So this is my amazing day, and we enjoy a lot of. Thank you so much. That's all.
Good evening, ladies and gentlemen, Professor ma'am, our faculties, the HOD sir, and my dear colleagues. A very warm evening to all of you. This is Rushda Rahman from PG semester 3rd, and what? Okay, sir. In today's technical session, it is very excellent. Very learnful, very helpful for us because we all have just initiated our master's course here, so we don't know that much about what we learned here, what they presented here, but it's very inspiring, and we learned a lot from it as TFT and cutting edge material. What we really don't know that much about it, but we learned it, and we learned it very truly. Thank you to all the dignitaries who are here with us and who inspired us for the further work, and we heartily thankful to all of you. Thank you.
Good afternoon to all. Honorable VC sir and Honorable Pro VC ma'am, head sir and all staff, faculty members and organization committee. I am very thankful to join this conference to give me opportunity, and the environment here, the academic environment and academic facility is very excellent, and especially the theme of the conference fulfill today. Here is the various type of lecture organized today based on chalcogenides, graphene, nanomaterials, some mathematical lectures also conveyed today. So overall, the experience of today is very excellent for me, and thankful to organization committee. Thank you.
Good evening, Honorable Pro BC ma'am, and all the dignitaries present here, and all my friends. Throughout the process, till it was announced that we are going to organize a seminar, it has been excitement in all of us, and finally we have achieved it. Throughout the process, it has been a term of learning with rejuvenation. We were very much excited for this day, and our head sir, our convener, gave us all the opportunities to learn new things. And most importantly, I would like to thank Pro VC ma'am that she started an era of learning. Thank you so much, ma'am.
Good evening to everyone. My name is Venu Gopal and I am a third semester student here. Today I was thinking about when the seminar was happening that what will be learned from the seminar. The main motive was to learn something new about material science. And even though after the seminar, few students, those who have learned, congratulations to them that you have fulfilled the perspective, the purpose of this seminar, that you learned something about material science. Either it's about nanotechnology or it's the structural composition of that material. You have learned something, and I have also learned something. So that for that, this was a very beneficial seminar for us all. And thank you, ma'am, for providing this opportunity to us. Thank you all.
Respected Pro VC ma'am and all the dignitaries. Today, this is my first seminar and I feel like that I am in a heaven. Why? Because from the beginning of my childhood, I was always only thinking. When I complete my graduations, that I know that. So only you have to be pass out with the help of the paper copy books and now you're gaining the knowledge. But when you are surviving in this world, you are the part of this nature. You are the human beings. You can think. You can learn a lot. You can make the changes. What the things is happening in our natures. So I could not be get anywhere that they are supporting for the developing of the nature. They are supporting for the thinking levels. They are supporting for the academic levels. You have to be completed. You have to complete your PhD. You have to complete your doctorates and many more degrees. Then you will get the job. We all are fighting for the job. And what is the job? Only for the doing the work, but the useless work. We are the great part of these natures. We are the unique ones. We are the different characters from all the animals. We are surviving in this world. Either they are surviving in the Mariana Trench or either they are surviving in the Mount Everest. So we have a different kinds of thinkings, and we should to be focused. Here I learned a lot. Why? Because I have seen that all the delegates and all the participants are proposing their proposal, which is their research work. So they are focused on the researchings. So I learned ocean of the knowledge, and also it's give me a power, it's give me a potential to increase my thinking. I want to be develop something that is called the mass. We already know that from the beginning, from the childhood, you have heard about the mass, but nobody know that how the mass is formed. So everyone know that the substance is formed with the help of the electron, proton, neutron. But I also know that it is the composition of the hydron, leptons, baryons, and many more particles. I have learned, I think, the 63, 64 particles, their nature, their spin quantum numbers, their iso spins, many more. But no one can explain what is the mass, how the mass is composed of, why they are the static characteristics. So when I was trying to know that, then I learned that boson particles, a scientist name that is called the Peter Higgs. The Peter Higgs is a great scientist, and he theoretically developed thinks that the mass is composed of the boson particles. But later on, there is no any believance and in 2011, when they are they experimentally proved that there is the existence of the boson particle which compose the mass of the anything, either the living organism or either the non-living organisms, and there is no any difference between living and non-living organisms. We already know that if there is a motions, then there is a living organism. No, it is not possible. There is a movements in the virus that it is a living or non-living. You could not determine it. Why? Because it is composed of the DNA. When we are talking about the DNA, then you could not be explained more and more about that. So when you are trying to get the something, you must have to be know the various facts and their details. So after the learning about the Friedrichs, I know that how the mass is composed of. It is formed by the boson's particle, and it is popularly known as the God particles. And that kinds of things is that means today's work always encourage me to do the same. Thanks a lot to all of you.
Thank you, Avinash. Now I would like to invite our online participants. Mufid Jasman, can you share your few words?
Yes, sir.
About this seminar, as we have our dignitaries on the dais. Mufid Jasman.
Hello.
Mufid, can you share your few words about this national seminar?
Hello.
Mufid, am I audible to you? Mufid, am I audible to you?
Yes, sir. Yes, sir.
Can you share your few words about this national seminar?
हाँ सर बहुत काफ़ी कुछ मटेरियल साइंस के बारे में जानने को मिला और सर बट मेरी प्रेजेंटेशन रह गई
बिल्कुल आपकी can you share your presentation in 5 minutes?
Yeah, sir. Give me only 5 minutes, sir.
Please, ma'am,
can you give me 5 minutes, sir?
Yes. Please do. Yes. नहीं repeat नहीं होगा. कुछ रह गया है.
Yes, sir.
Okay, wait for a few minutes, 1 or 2 minutes.
Okay.
1 minute.
Okay. Sir, is my slide showing here?
No, we are not able to see your slide. Start your.
Sir, can we सर क्या मैं मोबाइल से यूज कर लूँ अपने क्लिक का?
You can do.
Yeah.
Any means.
1 minute. Yes, sir. 1 minute. चलो देखो जी हाँ यार
Mufid, please present yourself.
Hello.
Mufid, we are hearing you. Please present yourself.
सर क्या स्लाइड शो हो रही है वहाँ पे?
No, your slide is not showing here. We are not able to see your slides.
हो रही होगी सर? ये हो रही होगी सर?
Please share your slides. We are not able to see your slides, Mufid.
सर आराधना झा के नाम से देखिए सर शो हो रही होगी.
आराधना झा
के नाम से देखिए सर शो हो रही होगी.
Mr. Ganesh, ये आराधना झा, please focus आराधना झा. ठीक है मुफिद, आप अपना स्लाइड शेयर कर देना ग्रुप में। ओके ओके।
यस सर। यस सर। हाँ हेलो। हेलो,
आप अपना परिचय दे दो। हाँ फर्स्ट स्लाइड में है। बोलिए बोलिए।
Okay, sir.
आपको बोलिए।
Yes, yes, sir. Sir, my name is Mufti Zuma, and today I present the structure and magnetic properties of chromium doped due to thin film under the guidance of Dr. Singh and Dr. Rada Shai, sir. Okay. These are my contents.
Mr. Mufid, please hear one thing.
Yes, sir.
We have a time constant of 3 minutes only. 2 or 3 minutes.
Yeah, okay, sir.
Okay.
Yeah, okay, sir. These are my content, and without wasting time, to the main topics. Introduction. What is metal insulation transition? Some materials have a tendency to they behave in metal as well as insulator at a particular temperature. Beyond this temperature, they have a insulating phase, and at a particular at the above temperature, they
sorry to interrupt you. Sorry.
Which is first discovered by the FMO in 1959. The metal insulation transition at critical temperature for CO2 is near about 341 Kelvin, which is for bulk, and it is about 336 Kelvin for Benjamin thin film. The reduction in the critical temperature is due to the strain of the strain.
Mufid, there is
at a temperature below critical temperature, it is in monoculic structure, and above it is a rutile type tetragonal structure. The uses of due to MIT behavior, there are several uses of BO2 material like
Mufid, I'm sorry to interrupt you.
Storage devices, smart window, and what. But due to high
Mufid, I am sorry to interrupt you. There is echo from your side. Mufid, I am sorry to interrupt you. There is a large echo from your side.
Yes, sir.
Mufid, I am sorry to interrupt you. There is more echo from your side. We are not audible you. We are not able to audible you. I am stopping here. Sorry to say. Now I shall call Professor Pramod Kumar Mishra sir. Sorry, Professor Arun Kumar Mishra sir, for his placing.
Hello. Hello, sir.
Mufid, please stop your talk. Actually,
Hello.
there is too much echo from your side. Please stop your talk. Please stop your talk. Please, sir, come.
Sir. Hello.
ये दोबारा इंट्रोडक्शन की कोई फॉर्मेलिटीज़ करने की ज़रूरत नहीं है। इस तरह का सिम्पोजियम बड़ा वेलकम स्टेप है। दिस इज़ ए वेलकम स्टेप। इससे लोगों को काफ़ी जो यंग स्टूडेंट्स हैं पर्टिकुलरली उनको बहुत इंकरेजमेंट मिलता है। दे विल नो हाउ टू स्टार्ट देयर वर्क। और इससे ये भी होता है कि दुनिया में कहाँ पर क्या काम हो रहा है। आप लोग डीएनए मॉडल के विषय में नाम सुना होगा आपने। उसमें एक वॉटसन है और एक क्रीक है। क्रीक वो जो फिजिसिस्ट, वो इसी तरह के किसी सेमिनार में गए थे और वहाँ पर जो बातें हुई उससे उनको लगा कि फिजिक्स इज ऑल बट ओवर। उनको ऐसा लगा कि फिजिक्स में बिल्कुल जो ओरिजिनल फिजिक्स में अब कुछ ज़्यादा करने को है नहीं। हालांकि आप देख रहे हैं आप नैनो मटेरियल्स पर या सुपर कंडक्टिविटी पर, हाई टेम्परेचर सुपर कंडक्टिविटी पर अभी भी काफ़ी एक्टिविटी है। क्वाज़ाई क्रिस्टल्स पर काम हो रहा है। तो उनको लगा कि हमको फिजिक्स से अब अलग होना चाहिए। देन ही स्विच्ड ओवर टू लाइफ साइंसेस और उनको नोबेल प्राइज मिला। तो इस तरह के कॉन्फ्रेंस में आकर के ही आप सीखते हैं और आपको अपना माइंड मेकअप करने में सुविधा होती है कि कौन सा फील्ड को हम पकड़ें जिसमें हमारे लिए कुछ चांसेस है। तो ये दिस इज़ अ वेरी वेलकम स्टेप। लोगों को बोलना भी सीखना इसी से होता है, क्योंकि बहुत से लोग जो हैं वो बोल नहीं पाते हैं। अभी भी मैंने देखा कुछ लोगों को बोलने में दिक्कत हो रही थी, तो सब जब होगा तभी तो सीखेंगे। अब्राहम लिंकन जब पहली बार बोलने गए थे तो 3 बार उन्होंने कहा था आई कंसीव, आई कंसीव, आई कंसीव, और बोल नहीं सके। तो किसी ने कहा कि यू कंसीव थ्राइस बट यू कुड प्रोड्यूस नथिंग। तो इसलिए ये कोई बहुत बुरी बात नहीं है, आप नहीं बोल सकते हैं तो नहीं बोल सकते हैं, लेकिन आप इसी तरह के किसी आयोजन में बोलना भी सीखते हैं। इसलिए इसमें यंग लोगों को आना बहुत ज़रूरी है, और इसको इसीलिए मैं कहता हूँ कि ये सब चीज़ पहले होता नहीं था मिथिला यूनिवर्सिटी में। इधर विगत कुछ वर्षों से शुरू हुआ है, इस तरह का छोटा मोटा एक्टिविटीज़ होना चाहिए। नेशनल सेमिनार, नेशनल साइंस डे होता है 28 फरवरी को, हम लोग उस समय कुछ छोटा मोटा कार्यक्रम करते रहते थे। मनी कंस्ट्रेंट होता है, लेकिन छोटा मोटा कार्यक्रम इस तरह से होते रहना चाहिए, और इससे विद्यार्थियों को बड़ा अपलिफ्टमेंट होता है। थैंक यू।
Thank you, Professor Arun Kumar Mishra sir, for your kind words and blessing for all of us. Now I would like to call Honorable Pro Vice Chancellor Ma'am, Professor Dolly Sinha Ma'am, for her kind words and blessing for us.
एक बार फिर सभी को मेरा नमस्कार एंड गुड इवनिंग। मंच पे उपस्थित हैं विभाग के विभागाध्यक्ष प्रोफेसर अरुण कुमार सिंह, प्रोफेसर, अच्छा ये आज चेंज हो गया फिर, अच्छा सॉरी, प्रोफेसर NN चौधरी सर आज आ गए हैं सर, विभागाध्यक्ष, और हमारे पूर्व विभागाध्यक्ष प्रोफेसर अरुण कुमार मिश्रा सर, कन्वीनर ऑफ दिस सेमिनार डॉक्टर रितेश चौरसिया, अन्य शिक्षकगण, प्रिय छात्रगण, और जो ऑनलाइन हम हमसे जुड़े हुए हैं पार्टिसिपेंट्स और डेलीगेट्स। मुझे बहुत खुशी है कि भौतिकी विभाग ने ये कार्यक्रम बहुत सफलता के साथ संपूर्ण किया। इसके लिए हम आप सबों का अभिनंदन करती हूँ, बधाई देती हूँ। प्रिय छात्रों, इस तरह के कार्यक्रम जो है ये इसमें आप ही के लिए होता है कि जैसा कि हमारे मिश्रा सर ने कहा कि आपको इससे रास्ता चुनने में आसानी होती है। आप जब पढ़ाई करते हैं तो आपको समझ में नहीं आता है कि ये टॉपिक मैं क्यों पढ़ रहा हूँ, ये इस टॉपिक में हमारे सिलेबस में क्यों रखा गया है, आज के दिन में इसकी क्या स्थिति है, क्या रिसर्च हो रहा है इस टॉपिक से रिलेटेड एरियाज में। इस तरह के सेमिनार्स और कॉन्फ्रेंसेस जब होंगे तो आपको पता चलेगा कि क्या हो रहा है, आप ही के एज ग्रुप के लोग कहाँ कितना अच्छा काम कर रहे हैं, तो उससे आपको मोटिवेशन मिलता है। इन्हीं सबको सोचते हुए विश्वविद्यालय ने 2018 में CBCS कोर्स को अपनाया, और MSc में अब आप देखते हैं, आप यू आर फॉर्चुनेट कि आप CBCS कोर्स के अंडर पढ़ रहे हैं। पर्टिकुलरली मैं एड्रेस करना चाहूँगी जो सेमेस्टर 3 में है। आप जब सेमेस्टर 4 में जाएंगे तो आप पाएंगे कि सेमेस्टर 4 में देयर आर ओनली 3 पेपर्स, एक EC1, EC2 और एक जो है वो AECC2 है, सॉरी डिसिप्लिन स्पेसिफिक इलेक्टिव है या जनरल इलेक्टिव है जी। तो आपको इसीलिए 4th सेमेस्टर में कम पेपर दिया गया है कि EC1 और EC2 को मिला के आप कहीं भी जाके प्रोजेक्ट वर्क कर सकते हैं। आप अभी 3rd सेमेस्टर में हैं, अभी से कोशिश कीजिए कि किसी अच्छे लैबोरेटरीज में आप इंटर्नशिप कर सके कोई विषय पे। तो इस तरह का कार्यक्रम जो आज हुए, आज का युग जो है एक तरह से मटेरियल साइंस का युग है, तो आपको आज काफ़ी कुछ मालूम हुआ होगा कि मटेरियल साइंस में किस किस एरिया में रिसर्च हो रहा है। कई डेलीगेट्स ने आपको संबोधित किया और उसमें आप जान रहे हैं कि कहाँ किस तरह का काम हो रहा है। और आगे की भी इस तरह के कार्यक्रम कीजिए जिससे आपको रास्ता दिखने लगेगा, आप अपने लिए कहाँ जाके इंटर्नशिप करेंगे, ये सब आपको काफ़ी सुविधाएं होंगी। जब आप किसी अच्छे लेबोरेटरी में इंटर्नशिप करने जाते हैं तो आपका लाइफ बदल जाता है। मेरे कई स्टूडेंट्स ऐसे हैं जो इंडियन एकेडमी ऑफ साइंसेस के उनको फेलोशिप मिला, समर फेलोशिप करने गए या इंटर्नशिप करने गए, उसके बाद वो वहीं एब्जॉर्ब हो जाते हैं, वहीं से PhD करते हैं, फिर फॉरेन भी जाते हैं, कुछ लोग जो होते हैं थोड़े देश प्रेमी होते हैं तो वापस भी आते हैं, और हम भी आशा करते हैं कि आप बाहर जाके जो कुछ भी सीखिए, वापस जरूर आइए और अपने देश के प्रगति के लिए काम कीजिए। तो एक तरह से इस तरह के कार्यक्रम रेगुलर होना चाहिए। मैं तो बोलूँगी कि आप जैसे अल्टरनेट वीक्स या में सैटरडे आफ्टरनून में एक सेमिनार सेशन रखिए, और वहाँ टीचर्स भी सेमिनार देंगे, किसी की एक विषय पहले से चुन लीजिए, उस पर टीचर भी बोलेंगे और छात्र भी बोलेंगे। पहले से शेड्यूल बना लीजिए, हर वीक मान लीजिए 2 ही छात्र बोलेंगे, तो इससे आपको बोलने की कैपेसिटी भी बढ़ेगी और आप कुछ पढ़ेंगे भी। जब आपको टॉपिक पे बोलना होगा तो कुछ न कुछ पढ़ना भी होगा। तो हम चाहते हैं कि इस तरह का कार्यक्रम विभाग में रेगुलर हो, और एक बार फिर आप सबों को ढेर सारी शुभकामनाएं। धन्यवाद।
Thank you so much, ma'am, for your such a kind words and blessing for all of us. We have time constraints, so I would like to call Dr. Surendra Kumar sir for the vote of thanks.
आदरणीय प्रतिकुलपति महोदय, जो फिजिक्स की विदुषी हैं, वैसे तो मैम ये विश्वविद्यालय की ही गार्जियन हैं, अभिभावक हैं, लेकिन इस फिजिक्स डिपार्टमेंट का अधिकार ज़्यादा बनता है, बीइंग ए स्टूडेंट ऑफ फिजिक्स। और हम लोगों ने फील किया इस बीच में, इस सेमिनार के क्रम में हम लोग कई बार जॉइंटली मैम से मिलने गया भी, और हम लोग संदेह भी व्यक्त करते रहे कि कैसे होगा, क्या होगा। तो कहती थी कि अरे कुछ नहीं होता है, साइंस में कुछ गलत नहीं होता है, करो ना तुम लोग, सब कुछ ठीक हो जाएगा। और हम लोगों ने फील किया, तो आप प्रेरणा स्रोत हैं हमारी, और आगे इसी तरह का आशीर्वाद और स्नेह हम लोगों को इस फिजिक्स डिपार्टमेंट को, वैसे तो पूरे विश्वविद्यालय को ही मिल रहा है, लेकिन फिजिक्स को मिलता रहेगा। आपका आशीर्वाद, आपका स्नेह उम्मीद करते हैं, आशा करते हैं। डॉक्टर अरुण कुमार मिश्रा जो हमारे गुरु भी हैं, रिटायर कर चुके हैं, आपकी उपस्थिति से इस सेमिनार में 4 चांद लगा। सर आप पटना से आए, इसके लिए आपको धन्यवाद। संयोग हम लोगों का बड़ा अच्छा रहा। आज के सेमिनार में हमारे विभागाध्यक्ष भी उपस्थित हो गए, सर मेडिकल में चले गए थे, तो यह आप सबों के लिए बड़े सौभाग्य की बात है, हम लोगों के लिए भी सौभाग्य की बात है। सेमिनार के जो प्रेसिडेंट थे हैं डॉक्टर अरुण कुमार सिंह जी, उनकी तत्परता आपने देखी, काफ़ी तत्पर रहे, सारे काम में दिन रात लगे रहे। और हमारे यंग और एनर्जेटिक जो कन्वेनर हैं, उनके लिए तो मेरे पास शब्द भी नहीं है कि मैं किस शब्द से मैंने इनकी सराहना करूं, इनके कामों की सराहना करूं। और सबसे ज़्यादा क्रेडिट यदि किसी को जाता है तो वह आप लोगों को जाता है, हमारे छात्रों को जाता है, हमारी छात्राओं को जाता है, क्योंकि हमने जो देखा, दिन रात आप लगे रहे। पिछले 1 वीक से हमने देखा है कि हमारे बच्चे लगातार, बच्चे बच्चियां लगातार कार्य करते रहे और इसको सफल बनाए, और आप लोगों की उपस्थिति ही इसकी सफलता है और थी। तो मैं आप सबों को हृदय से धन्यवाद देता हूं। हमारे गणेश जी बैठे हुए हैं, इनके बिना तो शायद यह कार्यक्रम सफल नहीं होता। मैं इनको भी बहुत बहुत धन्यवाद देता हूं। विनय बाबू भी काफ़ी एक्टिव रहे, जो मीडिया पर्सन्स थे सारे एक्टिव रहे। मैं सबों को हृदय से धन्यवाद।
Thank you so much, sir, for the kind words, blessings, inspiration, everything. It will be continue. Now, with the permission of Pro Vice Chancellor Ma'am, I would like to conclude this session, and I would like to close this glorious event. Ma'am, with your permission, thank you, ma'am. So it's official statement. We are closing this glorious event. Thank you so much. For a group photo in the portico, please collect yourself there.
वाला
बंद कर दे, स्ट्रीमिंग बंद कर दे। हाँ, वो पार्टिसिपेंट लोग अपने ना प्रेजेंटेशन है।
हाँ, अब कुछ नहीं है, अब
क्लोज कर देना। श्योर, एक मिनट।